Grade 12 Mathematics Paper 1, November 2020 final paper. So this is what we are going through today. Okay, so let's just get into it without wasting any time. Okay, so let's see. So the quickest paper was the where are you going? Was the what? Well, question 1. Let's see how let's see how fast we can get this one done. And then I also need to be careful not to make like useless mistakes, because why? But anyway, so 1.1.1 free 2 marks. How many marks? 2. So here we have x squared minus 6x. I mean, that was very nice of them to give such a question. But anyways, here we are. X is equal to 0 or x is equal to positive 6. So the one thing to take away from this paper is that you just want to make, you just want to look out for tiny errors and, tiny mistakes, because those are somewhat very inevitable. So don't kill me. Don't, chop my head off or anything like that. Also belief. Anyways, solving for x here, we have x squared plus 10x. And I'm assuming this is the part everyone skips because it's like, solving for x. Why? We want to see the bloody stuff, the stuff that are difficult and whatnot. But anyways, here we are, the quadratic formula 2a. So x here is going to be minus b plus minus b squared minus 4ac, the whole thing over 2a. Okay, let's see what this is going to look like in our calculator. But let's see here. There's the calculator. There we go. And yeah, I'm trying to be fast, but at the same time, I don't want to make silly mistakes today. I'm going to try and avoid silly mistakes. I'm going to avoid them like the plague. And the best way to avoid silly mistakes is to focus. But as I said, focusing, and while you're talking, you see here, I didn't even close this bracket. And the funny thing is, whenever I look at these, let's say after I've like done them, maybe I'm looking at a portion. One thing I notice is it's easy to focus on like the writing, and with the writing and the talking, it's so easy to make a mistake. But anyways, x is equal to this, or x is going to be equal to, let's see here, minus negative 9.12. Okay, moving on. 3 marks, you get them and you keep moving. So here we've banked about 5 marks in less than 5 minutes. So good, we're banking time, because that's the name of the game. You gotta bank your time. 1.1.3, it's an inequalities question. So this is like a basic inequalities question. I mean, if you have gone through the inequalities playlist, rather, this is child's play, because I mean, like, what is this? But anyways, for you to answer questions like this, what you want to do is, remember, this is just a quadratic graph that has been factorized. So what you want to do is, you want to firstly get the roots here. So getting the roots here, you want to work with mistakes. I've started so early. It's like less than 5 minutes into the video. So let's get the roots here. X is equal to 1. The other one, it will be x plus 2. Let's get the root here. X is equal to negative 2. So these are not our answers, remember. These are our roots. This is telling us that on a number line or in a Cartesian plane, we need to go to negative 2, make a dot. Positive 1, make a dot. This, we need to figure out, is it a frowning graph or a smiling graph? So to do that, we have no choice but to FOIL everything out. 1 times that is x. 1 times that, 2, positive 2. This times that is a negative x squared. This times that is a negative 2x. So clearly, I mean, hello, negative 2x plus x, that's like negative x. Well, we are dealing with a frowning picture here, so we have a frowning image. Ooh, nice. Supposed to be an arrow. An arrow. There we go. So it's a frowning picture, and this question is basically asking you, where is your graph below 0? Where does your graph have y values that are below 0? So you see it's below 0 here, it's below 0 there. So the x values where that's happening, it is where x is technically smaller than negative 2 or where x is bigger than 1. So normally most people like to write these all in one line. So you can write it like this. That's perfect. You could have written it like x needs to be big. We said smaller. X needs to be smaller than -2, or that x value needs to be bigger than +1. You can write it like this. You could have also written it like, so let's say here option 1, option number 2. These are just options, you see. Option 1, option 2. Option 3, you could have written it like x is an element of yeah, this one won't, it doesn't look like it will do for now. So let's leave that last one. So these are the two options you can give this as your answer. X needs to be smaller than -2, or x needs to be bigger than 1, or here x needs to be smaller than -2, or x needs to be bigger than +1. So I know if you're playing this at like 1.5 the speed, then yeah, baba, we're blazing, we're moving, we're not taking any prisoners, because we have no time for these malanyana questions. We want to get to the big ones. But anyways, x here plus 18. Me pen, don't do this to me. We just started. X minus 2. Oh my goodness. Okay. Let's change a pen. Let's change a pen immediately, because we ain't about to play those games. Like, let's see. Okay, gotta substitute. So here we need to also make sure we always write our questions properly, because obviously if you don't write your questions down nicely, it's chai. It's chai. It's gone. It's over. Finito. 5 marks. So anyways, we can square both sides here. Square here. Square here. This cancels that. This is like x plus 18 is equal to x minus 2. X minus 2. X plus 18. I don't want to leave any steps. So let's just do this. Minus 2x minus 2x plus 4. And then this is like x plus 18 is equal to x squared minus 4x plus 4. This is like x squared minus 4x plus 4 minus x minus 18 is equal to 0. And then here you have like x squared. Whew, I should calm down. Okay, or not. Why you calm down? Why you gotta calm down? This is like a whatever you want to call it. So there's no time to be calming down here. Like no time to be calming down at all. But anyway, solving for x here, we clearly just need to use the quadratic equation again. So let's just write it out, because it's always a good idea to write out the quadratic equation or the quadratic formula before you use it, because you want to keep your examiners happy. You see, the idea with an exam is, yeah, it's like communicating with your examiner, you know. You don't want them to be, well, technically any examiner is not like gonna be confused as to what you did if you were to use like the quadratic formula or anything. But I mean, whichever way, you know, you have to, yeah, just pretend they don't know. So whatever you do, just try and make sure you're communicating properly. So here we have like negative b plus minus b squared. Hey, what happened there? Squared minus 4. Our a value is a 1. Our c value is a negative 14. Whew, you can see, 2 here and then 1. Need to be careful here. X is 7. Okay, thank you very much. Or x is what? X is negative 2. Negative 2. So you see, whatever x values we're getting here, we need to be aware that we need to be careful, because you see here we're dealing with a quadratic. We're dealing with something that's under a square root symbol. So if you check here, let's see here if negative 2 would work. Negative 2, if you check, you see with the main expression, if this was a negative 2, then we would get negative 2 minus 2, which is like a negative 4. So let's sub in these values to see if the equation balances. So let's see here, Balenciaga. Let's try the 7 first. 7 plus 18. Let's see here, 7 minus 2. Whoa. 7. Oh, there's a square root there. 18 plus 7. This is like square root of 25. 7 minus 2. So yeah, the 7 works. So you keep it. Ka-ching. The negative 2, however, is clearly not going to work, because, I mean, like, look at that. Negative 2 here plus 18. Let's see if it's equal to negative 2 minus 2, because we're just subbing it into the original one. You see, put a negative 2 there, and then we put a negative 2 over there. And then what you're gonna do now, you're gonna put a negative 4 there. This is technically, I mean, you cannot have a negative under this thing, so this is like gonna be 16. This is like 4. It's not equal to negative 4, so not valid. Don't leave it alone. If you left it alone, then clearly you would be in trouble, because yeah, that's it's not working. But anyways, moving on to the next question, because we are not wasting time. You see, 10 minutes, we have 5, 8, 10, 13 marks in 10 minutes, so it seems to be good, because this should have been this should have taken us 13 minutes roughly. But anyways, oh yeah, solve for x simultaneously, solve for x and y simultaneously. Classic. Yeah, you know, some of these, I mean, if you can see how predictable question 1 is, there's no ways you should go through an exam math paper. There's no ways you should write out a math exam without I'm talking, but I'm wasting time. I don't know what to do. Let me write down the sum. Yeah, so what I'm saying is, you see how predictable all these papers are. They're like super 100% predictable, especially, I mean, question 1 in particular. So always make sure that you get all your marks for question 1. I mean, at least 90% of the marks, 80% of the marks. That's a good chunk, you know, because I mean, you know exactly what they're gonna ask. They're gonna ask a very basic solve for x question, and then they're going to ask a slightly more basic one, and then they are going to try and finesse you with the inequalities question, blah 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 blah. It's all too predictable to not get easy marks. So here, let's isolate. I want to isolate. Let's isolate x, because here it looks like it doesn't matter. 3 minus y. So this, we're gonna throw it into that. So this is gonna be 2. Here you just want to be careful with your signs, because with you see here, I made sure I put a minus there, and then when you're subbing in values into your other equation, always keep in mind your signs. And here you see, don't make the mistake of saying 3 squared minus y squared. No, this is telling you that you have 2 big brackets, so don't put the square inside here. What I like to do is, let's write the 4 and the y together. You see, it'll make our life easier. And then minus y is equal to 15. So here, I would prefer leaving the 2 out. Let's leave it there. 3 times 3 is like 9. This times this is like negative 3y, negative 3y plus y squared. Oh, tilted. And then let's close this. Don't mind the square brackets. If you put round brackets, that's also fine. I mean, it's not a big deal. Negative 4y squared minus y is equal to 15. So remember, as mentioned, if you spot any tiny error, just hold on for like a few seconds or a minute or so. I'll probably spot it after you, because I mean, you know, because you have good eyes, and we are just finessing our way through life here. But anyways, 11, oh snap, what am I doing? Yeah, 12 minus y. 12y minus 1y is like 11y. Let's put a minus 4y squared is equal to 15. So yeah, I'll repeat. If you spot an error, I'm only gonna spot it later, so yeah, don't chop my head off, please. Anyways, is equal to 15. So here now I need to be careful, you see, because I'm trying to be careful here. This minus this, that's going to be negative 2y squared. Negative 12 plus 11, that's going to be like negative y. And then let's take the 15 over. So it's going to be 18 minus 15. The pause. It's a positive 3. Woo-wee. Yeah, you see here, I need to pause and check what I did, if it's correct, if there are any small dumb errors, because I've made a lot of those so far, and it's like so annoying. It's so painful when it's like, when you check in the comments and like, oh, this timestamp, and you're like, oh snap, minus b plus minus b squared minus 4ac. And then yeah, I'm assuming that most people already passed this part, probably skipped it, went straight to all those other slightly more, you know, hectic questions. But here we are, minus b plus minus b squared minus 4ac. Okay, so this is looking crazy, but anyways, let's see here, 2y, and then y using the quadratic formula. Let's see what y is gonna be here. Negative 1 plus negative 1 squared minus, laat ek vir jou wys, negative 2, and we got the positive 3 there, and then 2 times negative 2. Let's hope I put everything in correctly. So negative 3y, and the best way to check at the end is if you sub in your values for y and x, and it has to balance, you know, Balenciaga. But anyways, minus, that's a 1. So test the answers. And you see, I feel like I'm being chased, which is fine, because in an exam, yo, that time will creep up on you like boom, and then you're like, what happened? So it's here, negative 3 over 2. This is like 3 plus 3 over 2. Trust me, use the calculator. Don't be a hero. Use it nicely. Plus 3. That's like 9 over 2. 9 over 2. This is for x. Or let's say x is equal to 3 minus 1. That's like x is equal to 2. So all you do is, I mean, it's best to use this one. Throw in x and y in there. See if it balances as well. So I'll use, let's use the fractions, you know. Let's be bold. This one and this one. Let's use these two values for x and y in our main expression. So you see, in our main expression, our x value, we got it to be 9 over 2. So let's put here 9 over 2. Hey, it's 9, not 6. And you see, me checking is not wasting time, because you need to check. You can't go on guessing that you did the things. You have to check. You have to double check. You have to be sure. You have to, you know, you must know. So negative 3 over 2. And then minus, you see, I'm using brackets as best as I can, or as wherever possible. This should give us 15. Ooh, look at that. It balances. Nice, fantastic. So this is like 1, and let's try that. We don't have to try it twice. Trust me, if it works out once, you're safe. So you move on. You are move on, and you are do the other questions. So, I remember doing this question. Let's see. It says, if n is the largest integer for this expression, determine the value for n. 1.3. So this question looks a bit weird, but it's actually a bit straightforward, because well, it is. I mean, just hear me out. Anyways, so with a question like this one, it's like we just need to solve for n. Solving for n, the best thing we can easily do is, let's put this with 200 here. Let's put this with 200 here. So this is going to cancel out, and then you're going to have n is smaller than, let's say here, 200. With this symbol here, 5, and then 300. Now the idea is this 200 can go under the 300, and then you have 5 to the power of 3 over 2. Now you may be asking yourself, how are you going to work this out without a calculator? Well, it's pretty simple. So this is what you do. You can actually, it's almost like you can reverse the process. Yeah, let's just do that so that we use smaller numbers. I think you may be a bit more comfortable that way. So the 2 went out again. This is just another method. So here you have a square root symbol, and then inside here you have 125. Now square root of 125, you can write it as 5 times 5 times what? Snap. I'm stuck. I'm proper stuck. No, 5 times 25. Goodness, what is that, dude? Come on now. So this clearly, you see, the square root symbol goes for the 5, the square root symbol goes for the 25, and then you have n needs to be smaller than 5. Why was I struggling when they did not say anything about not using a calculator? You see, they didn't say you can't use your calculator. Come on. Yeah, from here I could have just put everything in the calculator, and like from this point here I could have just put everything here in the calculator. Just wasted time. But anyways, you see, n there is not an integer value, so we have to check what's the closest integer number to this, which is just 11. So here we have to say, therefore, you see, the question was saying if n is the largest integer for which this side is smaller than this side, determine the value for n. So n is going to be equal to 11. Because if n is 11, this is the largest possible integer, where the left side is going to be smaller than the right hand side. Because the moment n is like 12, it's going to be bigger than this, clearly. Moving on, no big deal here, no big deal. So as we said, you could have put all this in the calculator from the get-go by doing shift this button. You go up there, you put your 200, you go here 5, you put a, where the 2 is, you can put a 300 there, and then boom. Math error. Oh, so you couldn't. Oopsie. But say if you tried it here, the reason why it's showing math error is because those numbers are too big. So if you had done it here at this step, if you had put that into the calculator, that would work. I mean, you see, boom, you see, boom, 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 you'd get your 11 there. The pen fell. But anyways, moving on to question number 2. Here we are, question number 2. Let us get it, I guess. So anyways, question number 2. What does question number 2 say there? Question number 2, it's a classic sequences and series question. Doesn't look like anything is happening there, but anyways, let's not underestimate anybody. This is an arithmetic sequence. This thing here, that 7x, y, da 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 da. They said it's an arithmetic sequence. So keyword is arithmetic sequence. Then they say determine the values of x and y for 4 marks. What a pity. Okay, it's fine. We'll determine those values. So clearly determining the values of x and y, you want to make use of what they told you. They told you that this is an arithmetic sequence. If they did not tell you that it's an arithmetic sequence, it would have been harder to get x and y. But the moment they tell you that, then use the laws of an arithmetic sequence. Like d2 is equal to t1 minus t2 minus t1, or you could say d is equal to t3 minus t2, going on and on and on. It doesn't matter. So let's use that law. So here we know that x minus 7 is equal to y minus x. So you see, x minus 7 is equal to y minus x. We can make this equation 1. The next equation we can say negative 11 minus y is equal to y minus x. Woo. Equation number 2. Now we can solve for x and y simultaneously. Well, in the previous question we worked out x and y simultaneously, but here we can just do the same. So let's use this equation here. Let's isolate y. Y looks like it's easier to isolate. So this negative x, if you take it over, it's going to be 2x here, and then negative 7 equal to y. So let's throw this in here. So you have negative 11 minus your negative 7. Let's see here. So we said what? Whoa, 11 minus the value for y, which is actually negative. No, it's not a negative. It's 2x. 2x minus 7 with a closed bracket, and then that is equal to whoa. You see, I'm disorientated because legit while I was recording I got a call and then it cut, and then I'm like carrying on from media. But anyways, this is equal to y as well, which is 2x minus 7 minus x. So here this is going to be negative 11 minus 2x plus 7 equals to 2x minus 7 minus 12. And then what you're gonna do when they come for you, 2 minus that's like x, and then plus this 2x, that's 3x. You see, this minus that's like x, and then x plus this 2, when it comes over, it's going to be 3x. Now the numbers, we can put them on one side. Negative 11 plus 7 plus 7. Calculator ain't even gonna bother. Like, let's see here, negative 11 plus 7 plus 7, because you see the 7 is going to go over, it's going to be a plus, so it's going to be, they say this is 3. So divide by x, divided by 3. Come on now, concentrate. X is equal to 1. And we said when we're done, I mean, we have to test all this if it stands, you see. I mean, yeah. So if x is equal to 1, then we can sub x into this equation. It's just like 2, 1 here, minus 7 is equal to y. That's like 2 minus 7. That's like y is equal to negative 5. So if you test this sequence, it should be 7, and then 1, negative 5, negative 11. Let's see if there's a common difference. It's like minus 6, minus 6, minus 6. It works out. So these are the two values for y. This is a minus 5, and then this is a positive 100. Fantastic. Let's move on. Let us not waste any time, because we've wasted way more time already. I mean, like, this is 2.1. I think obviously likely because this is going to be a brand new memo, I should, make it available for the other children to download. But anyways, yeah, the link to the memo is in the description, as in the one I'm writing out. Given the quadratic number pattern, okay, Determine the general term of the pattern in the form this. Okay, easy marks, I guess. We want to judge. -3 there, 6, and then don't be blurry, and then you got 27, and then you got 60. So getting the general term is the easiest thing you will always ever have to do, you see, because you have to get the first differences. 60 minus 27. Don't be a hero, use the calculator, you know, get it. 33. This, okay, yeah, 6 minus -3. You see when I pressed, you see when I said 6 minus, I use the minus button, and then here I say -3. You can put it in brackets if you want. So 6 minus -3 is just like 6 plus 3, so you see that's fine. Then here, I mean 33, that's minus 21, that should be giving it 12 as expected, and then this should also give you a 12, but you know, it doesn't hurt to double check. But okay, we have a second common difference. So this is what you need to do to start off in terms of getting your formula. You see your general term, Tn is equal to a plus, wrong, Tn is equal to an squared plus bn plus c. So to start off here, you're going to say this is equal to 2a, you say this is equal to 3a plus b, you say this is equal to a plus b plus c. And I say I'm going to share this memo, but look at it, I'm botching it. Hey, come on man, focus. This is a plus b plus c, ne? You want to start from the bottom and then end up here. 2a is equal to 12 divided by 2 divided by 2, a is equal to 6. And then you keep going up, you know, starting from the bottom, and then you keep going up. This is a 9, so this is like 18 plus b is equal to 9. And then b is equal to 9 minus 18, b is equal to -9. Now you're here, you see, so it's going to be 6 plus, okay, it's a -9, so let's put that in brackets, plus c is equal to -3. 6 minus 9, don't be blurry, please, thank you, plus c is equal to -3, and then this is like -3 here, plus c is equal to -3, and then it's like c is equal to -3 plus 3. C is equal to 0. Ooh, interesting. So here, therefore, Tn, here we have to definitely double check. 6n squared minus 9n, and then plus 0 if you want. You don't have to put the 0, but I'm just feeling funky. So let's test it by let's check what term number 3 is in our sequence. So it's going to be 6 here, and then let's see here, 3, let's throw 3 in there. 3 squared minus 9, 3 here. 27. Let's test term number 4. Term number 4. You see what we're doing? Whenever you can check your answers to see if they're correct, do it. 60. Okay, perfect. 4 marks. You keep moving on. No time to waste. This paper was actually quite good until here, I guess. Let's see the next one. Well, let's see how far good this paper was, because so far, it's a cake. It's a cake, it's a it's good, but hey, let me not talk too quickly. Let me not talk too soon. Show that the sum of the first differences of this sequence can be given by this. Ooh. Okay, so we need the sum of the first first differences. Oh, you see how I was like, wait, what? So what they mean is we need to use this sequence. You see, this is the sequence of first differences. So this sequence is 9, 21, 33. We need to show that in the SN formula, if we're going to attempt to work out a certain number of terms, we need to show that this is going to give us we need to show that this is a sequence for, not a sequence, a formula that will give us the sum of a certain number of terms in this sequence. So here, I mean, luckily we already know that this sequence is just a arithmetic sequence. So Tn is equal to, Sn is equal to n over 2, 2a plus n minus 1 d. So here, working out the sum of a certain number of terms, n remains n, a we know it's 9, n is n, d we know it's 12. So let's simplify this. This is going to be n over 2, don't be blurry, 18 plus 12, n minus 12. Hey, I see you. And then here, you have 18 minus 12, right? Let's see here, 18 minus 12. Think fast. I think that's positive 6. And then here, if you multiply inside, you see, you have to remember these are just over 1. So here it's n times 12, n that's going to be n times 12n is 12n squared. 2 times 1 is a 2. And this times this here is like 6n at the top over 2. And then clearly you can see if you simplify here, your value for Sn is technically going to be 12 divided by 2, that's like 6. And then 6 divided by 2, that's like 3. So it's like plus 3n here. And then if you check that out with what you have been given here, you see, it checks out. It's the same. You see, the question just said show that the sum of the first n first differences of this pattern can be given by this. So the sequence of first differences is this one here. You see, these are the first differences. The 9, the 21, and the 33. That forms a sequence. So we have gotten that one here. 2.2.3. Moving on to 2.2.4. For 4 marks. How many consecutive... we are getting into, you know, the territory. We are getting into that space where the questions start to show flames, I think. But let's be careful and read the question nicely before, because I feel like it's about to go down. Anyways, how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060. Moment of silence for all the hearts that dropped when this question, you know, creeped up and the paper was so good. But it's a 4-mark question, and the one thing we want to recognize is, okay, for this, what we have done here, firstly we have an Sn formula, right? Let's keep in mind this Sn formula. Sn is equal to 6n squared plus 3n. You see, technically at some point in time we are definitely going to need to use this Sn formula. So let's read the question again, because why not? So it said, how many consecutive first differences were added to the first term of the quadratic number pattern? How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060? Okay. So this question seems a bit tricky. I won't lie. So here they are saying, though, we need to work out how many consecutive terms, how many consecutive first differences were added. So in our sequence of first differences, so we have to keep in mind that we have a main sequence here. The main sequence is, let's look back there. It is -3, and then we have 6, and then we have 27, and then we have 60. So our sequence of first differences is technically this sequence here. We have, what did we have at that time? To the back here, it's 9, 21, and 33. So here we have 9, 21, 33. So you see, I'm going to take this question nice and slow. I'm not even going to rush for nobody. And you see, what I'm doing is what you also want to do. If a question is not clear, read it over and over and over. Well, here I'm not in an exam, so I can't just move on. But if I was, I would have moved on ages ago and then came back to this later. But anyways, it says how many consecutive first differences. So how many of these first differences were added to the first term of the quadratic number pattern? This question is super weird. It says how many consecutive first differences. So how many consecutive first differences? So how many consecutive first differences? So how many here? So technically speaking, they're talking about 9, 21, 33, going on and on and on. How many consecutive first differences? How many of these numbers, right, were added to the first term of the quadratic number pattern? So the first term of the quadratic number pattern is this number here. This is the first term of the quadratic number pattern. The first term of the quadratic number pattern is a -3. So they're saying how many, You see, I'm reading it over and over again. And now you must be thinking, dude, what the hell? You're annoying. Just go on. Yay. Chill. So it says here, how many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that has a value of 21,060. So the first thing I would do is I would take our Tn formula. Tn, we worked it out to be, where are you? 6n squared minus 6n squared minus 9n. Okay, let's see here. 6n squared minus 9n. I would take my sequence, my general term, right, for the quadratic number pattern, and I would firstly find out in our quadratic number pattern, where is this value to begin with? So 21 and 60 is equal to 6n squared minus n, and then here if you check 6n squared minus 9n, that's going to be negative 21,060. This is a 0. So here technically n is going to be minus b plus minus b squared minus 4ac over 2ac. Quadratic formula, it is everywhere. I always say math is like water. You know, it flows everywhere. There's nothing that you can say is restricted to a certain paper, or nothing that is restricted to like a certain topic. Anything and everything can be used everywhere in math. So try to keep that in mind. Squared here, minus 4. A value is a 6. C value is negative 21,060. So let's see here what all this is going to be in the calculator. Let's see here. Okay, calculator, give us some answers so that we can carry on with this question, because technically we have to get this answer and we need to analyze the question again until you're certain that what you're doing is correct. Because yeah, you see, again, this is why, again, this is one of those questions you never want to do while you still have the rest of your paper to do, because you see, they're not straightforward, so they're a bit vexing. So you don't just attempt them immediately, because you are likely to bump into a silly mistake. So I would have gone past this long time ago and came back to it later. So n cannot be a negative number, so let's just get that number and cancel it out, because it cannot be. So here it's saying technically what we now know is, right, 21,060 is term number 60 in our sequence here. You see, it's term number 60. So somewhere here at T60 we have 21,060 there, somewhere in our sequence. So here our question had said how many consecutive first differences were added to the first. Whoa. How many consecutive first differences were added to the first term of the quadratic number pattern? To the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that is this value. Okay, so what they mean is, technically, if you think of it, you see, we're starting at -3. So if you add 9, you get 6. You add 21, you get this. You add 33, you get this, going on and on and on. So can you see, to the first term, you are adding these values one by one, you see. So you're starting at 3, you added 9, you got this number. You added 21, you got this number. You added 33, you got this number, going on and on and on. So eventually you're going to add a certain value, and then you're going to get 21,060 as your answer. They're asking you how many of these numbers would we have added up together. So in our case, yeah, let's just read for the last time, I promise. How many consecutive first differences were added to the first term of the quadratic number pattern to obtain a term in the quadratic number pattern that is this value? So we need to work out in this sequence of first differences, right? Technically, all you want to do here is to work backwards, because you see, this is term number 1, term number 1, 2, 3, 4, going on and on and on and on and on. In this sequence of first differences, technically this is term number 1, term number 2, term number 3, going on and on and on until whatever this term is. So we can reverse engineer this. If what I mean is, you see, for us to get, so we're starting at 1, right? If you add 9, that's one term. And then for term number 2, you add a second number. For term number 3, you add a third number. For term number 4, you add a fourth number. So for term number 59, you added a 59th number, which is why this is 60. So let me repeat that process actually. You see here we are at 1 here. Term number 1, you add one number. Term number 2, you add a second number. Term number 3, you add a third number. Term number 4, you add a fourth number. So term number 59, you add a 59th number for you to get term number 60 in this sequence. So in this sequence of first differences, right, you added up 59 numbers for you to obtain 21,060 as a value in a sequence of in your quadratic sequence here. So here we got n is equal to 60, fine, because term number 6 is this value. But for us to get this term number 60, we would have added up 59 numbers in our sequence of first differences. So here, as an answer, we have to word it out nicely. So how many consecutive first differences? So here we have to say, therefore, 59 how do you spell consecutive? Consecutive first differences. Whew. Just for 4 marks, and you see, okay, it wasn't a lot of thinking, but I mean, yeah, I would have moved on and came back to it later, because, you know, in an exam, you want things to be flowing until a certain point in time when you know you have done everything. You know, you don't want to get hiccups early on. So this is all you needed to do for this question. Now we need to move on to question number 3. Well, here we are, question number 3 for 8 marks. Sigma notation. What's happening? Okay, so it says prove that this thing here is a convergent geometric series. Show all calculations for 3 marks. Wow, so this paper was actually quite friendly, in my opinion. I mean, let's not lie here, no cap. So here, the first thing is that the infinity symbol at the top is showing you that you're working with a sum to infinity question. And this is a 1, by the way. K is equal to 1. And then here you technically have the general term of a geometric sequence. So let's actually just write that down. So we have a sigma symbol, the sum of an infinite number of terms. Let's see here. Sum of an infinite number of terms where the sequence, why are you blurry? Who come say so blurry? Like, come on now. 4 times 3 and then 2 to the power of negative k. There we go. So this is the big idea. They want us to show that this geometric sequence is convergent for only 3 marks, which is simple. So all you need to do is you need to show that your value for r is bigger than -1 and your value for r is smaller than +1. You see, bigger than -1 or smaller than -1, or you can say whichever way. Don't worry about the wording too much. You just need to know that r needs to be a number between -1 and +1, where -1 and +1 are not included. So anyways, for us to get for us to somewhat get this worked out, or we need a value for r, right, to show that this middle part is going to satisfy this inequality. So getting a value for r, I would advise us to get the first 3 terms or something and then get a value for r, and not try to just see it from here, because that's a bit risky. So what I mean is get term number 1, term number 2, term number 3. Let's see what those terms are in this sequence. So it's going to be 4, 3, 2 minus 1, then 4 times 3, 2 minus 2, 4, 3, and then 2 minus 3. So here let's see what these terms are. Term number 1 is technically going to be, it's 4 times 3, which is just a 12. Man, I like my calculator, so this whole mental math thing, no, I don't like it. So that's a 4. So it's 12 and then 4. And then the next one is just, you see, this is like simple. This looks like doing something simple with the calculator, but hi baba, it's fine. So here technically our value for r needs to be this divided by this, or this divided by this. So here r is going to be 4 over 12, or this value divided by 4. So here 4 over 12, I mean in your calculator, 4 divided by 12, that's just a third. You see how weird this is? r is a third. And then here, if you wanted to use this one, you can just do that because it's 4/3 divided by 4. See, a third. R is a third. And you need to be certain that your value for r is whatever you've worked it out to be, because you don't want to guess it from here. So here you can see that, therefore, our value for r is a third here. So you see, a third is bigger than -1, and a third is smaller than +1. So our sequence is convergent because it satisfies this inequality. So here we can say, therefore, this is because this is happening. So our what is our question? Our geometric sequence is convergent. Our geometric sequence is convergent. Vergent. How do I spell convergent? Let's find out. Convergent. Yep, convergent. Fantastic. Moving on. No time to waste here. So this question was pretty simple. Shocking that they asked it, but glad they did. I mean, thank you for being kind. So now they are saying, if this is happening, right, if this thing here is equal to 2/9, determine a value for p for 5 marks. So we need to understand what is going on here. We need to understand very carefully. So remember, we said anytime you deal with sigma, right, you need to think of your SN formulas. But here it's a geometric sequence, and clearly it's a sum to infinity question. So with this sum to infinity question, they are technically telling us that the sum to infinity of a certain number of terms starting from p until infinity is this number. I'll say that again. The sum to infinity for a certain number of terms starting from p until infinity is equal to this value. You see, so here for 3.2, it looks too simple, right? I mean, it's like 3.2. I mean, do they really just want us to use the sum to infinity formula and then just get a value for p? Like, it just seems so simple. It's so fishy, but it's fine. It happens. It be like that sometimes, like legit. But anyways, this is what we need to do for this question because it's a 5-mark question. So if you remember what we said, the one key thing here is this is giving us the sum to infinity, right? Starting from a certain value. So what we would want to do, keeping in mind this is a 5-mark question, the big hint here is that this is a 5-mark question, so it is clearly not straightforward, unfortunately. So firstly, the first thing I would do is write down the sum to infinity formula. So that should get you a single mark. Sum to ooh, that's a terrible looking sum to infinity. It's a over 1 minus r. So what we know is we have a sequence here. We have a geometric sequence. Our value for r, well, if you recall from the previous question, we worked it out. We know what the value for r is. And what we also know is that this is the sum to infinity. You see, we're given the sum to infinity here. And we're given a value for r. Well, not given, we worked it out. Our r, we worked it out to be a third. What we don't know about this sum to infinity is what a is. We don't know what a is, and you don't assume that a is p. No, that's wrong. See, I'll repeat. Here we've been given the sum to infinity. It's 2/9. Our r value is a third. We don't know what a is. So before we do anything, it's best that we work out a value for a to see what is the first term in our sequence. So here our sum to infinity is 2/9. Our value for r, we know it's a third, and then our value for a is what we're looking for. So this is clearly a over 2/3, like that, 2/9, and then here we can multiply by 2/3 on both sides, times 2/3. This cancels that, so our a value, if you check, this is like what's 3 times 9? 27. Okay, so this is our value for a. So a, not p, see this is a. Don't get carried away, it is a. So now that we have a value for a, what we know is our sum to infinity is 2/9, where our a value is this, starting from this number. So this is our sum to infinity. So basically, if our sum to infinity is 2/9, starting at a specific value, we need to know what specific value is that in this sequence. So you see, we have a sequence here, right? Technically, Tn is equal to 4 times 3, and then there is 2 minus k. So in this sequence, right, we know that our sum to infinity is starting from where this is our first term. That's what you want to remember. We are taking this sequence, we're starting from a specific number, and then our sum to infinity is giving us 2 over 9. So for us to find out which specific number are we starting at, we know that we are starting from this number in this sequence. So we need to find out this number in this sequence, which position is it at? Because technically what you want to remember is originally, right, say you have a sequence here. Remember our sequence originally, if you check, it starts at 12 and then it's like 4 going on and on. So it's like 12, 4, 4 over 3 going on and on and on and on and on. If you are just working with this sequence on its own, say you wanted to work out the sum to infinity for our sequence starting from the very beginning, you would have said sum to infinity is equal to is equal to a over 1 minus r. You would have said your sum to infinity is 12 over 1 minus a third. And then here in your calculator, let's see what you're getting here. Remember here I'm making an example to explain what we're doing. So let's see here, 1 minus r, that's like 1 minus a third, let's see here, equal to 18. You see, so you see for our original sequence, if you work out the sum to infinity for our original sequence starting from 12, your sum to infinity is 18. With this scenario though, this scenario here that they're talking about, you're starting somewhere in your sequence, somewhere along the lines inside your sequence here, you have this number, right? This number here is 4 over 27. So if you start from 4 over 27 going to infinity, our sum to infinity is 2 over 9. That's what we have gathered so far from us working out this 4 over 27. This 4 over 27 is where we are starting if our sum to infinity is going to be 2 over 9. You see, we're starting from a specific value, and then that specific value is here. We want to find out in our sequence, right, where is this value? So to do that, we know that 4 over 27 is a term in our sequence. We want to find out which position is it at. So it's 2 minus k here. We can divide by 4 first on both sides. Well, here you can simply just put it in your calculator. 4 over 27 divided by 4. 4 over 27 divided by, 27, boss. 27. Stop trying to make me fail or something. 1 over 27. So here you can say 4 over 27 divided by 4. And then here you also have divided by 4. Yeah, it looks tacky. Let's not do that. Yeah, that's going to upset people. Rub the whole thing out. Oh, I'm so sorry. I'm so sorry. Don't kill me. But anyways, yeah, divide by 4 on both sides. Divide by 4. This is like 2 minus k. And then here you have 1 over 27. And then because you're trying to work out a value for k here, you can say, you put them, you can leave this, you can have 3 as your base for each of those values there. And then you can divide by 9 on both sides. So here you're going to have, let's write it here. Ooh, running out of space. Would you believe that? We are out of space. So let's put it here. 1 over 27 divided by 3 squared is equal to 3 to the power of that. And then here, let's see here, divided by 3 squared. 3 squared is just a 9. So let's see here. 1 over 253. Ooh, 43. 1 over 243. Let's see here. 1, 2, 43. And then you have 3 negative k. I mean, to work this out, I would just use logs because, you know what, it's fine. I'll just use another page. I don't need to squash everything in like something that does not have paper. So this is 243 is equal to 3 negative k. So using logs, we can leave the exponent on its own, log the base, and then the value. And then here is negative k. Put all this in the calculator. Let's see here, log 3, 243. No, it's not a times. Come on now, don't do that. Come on. Negative 5, which is perfect because you see we're going to divide by a negative on both sides anyways. So this is telling us k is equal to 5. Whew, crazy question, this one. So to end things off, you see, our k needs to start off at 5 for our sum to infinity to be 2 over 9. in this sequence, you see. So therefore p is equal to 5, because what we have gathered is in our sequence, right, our sum to infinity is this if we start off at a specific spot. But before us knowing which spot we should start, we need to know where in our sequence, right? Where in our sequence do we start off at if this is our sum to infinity? Because this is a sum to infinity if we start at a specific spot in our sequence. So we have found out which spot that is, somewhere at 4 over 27. So 4 over 27 is a number in our original sequence. And we said if you get 4 over 27 as your first term, right, your sum to infinity will be 9 over 2. And then we said this value would be at position number 5, you see, which is what your value for k needs to be. Your k needs to be equal to 5. And then where p is, we know that's where the 5 would go. So p is a 5. So you see, this was genuinely a complicated question. I mean, it's out of 5. So again, yeah, if it's not your cup of tea, you also don't want to jump into these too early on. You want to finish your whole paper and then come back to them later. But that's all we needed to do for this question. Let me actually go up a bit so that everything can like come out nicely. Jeez, oh, that was weird. But anyways, let's move on to question number 4. Question number 4 now. Functions. Let's do this. So yeah, functions and graphs is one of the topics which I am making a full-blown course on, you know, because yeah, the course basically covers absolutely everything that you need to know about functions, especially if you're in grade 12, because with functions you can see it's one of the things in an exam that will make or break you. So with the course, it's from start to finish, every single thing you need to know about functions. So you can think of all the tutorials that I post on both of these channels. Now imagine a course, how much more comprehensive that is, because I mean with the tutorials on the channel, those definitely help, but then with the course it's like in-depth, starting from scratch, pretending that you don't know anything type of thing, and then we work things from there. So anyways, the course, the link to that is in the description. With this question, it says write down the equations of the asymptotes of h. So h is a hyperbola. A hyperbola has two asymptotes. There is an x asymptote where you take the opposite of this. There's the y asymptote where you take this the way it is. So for 4.1.1, your asymptotes, you're going to say x is equal to the opposite of this value. So x is equal to -1. That's the x asymptote. The other asymptote, you're going to say y is equal to +2 the way it is, because for x you take the opposite. Boom, thank you for saying that, because it made me see my error. So for x you always take the opposite. You see, x is equal to +1. For y you take it as it is, y is equal to +2. See, so these are the two asymptotes. You see, plural asymptotes, meaning you have two of them, hence why it's for 2 marks only. So this paper was quite fair. Goodness, how can they ask that? They asked this, and they, oh, whoa, they were so generous. Yo. Hey, yeah, you see all these things here, all of these are covered in the course. All this, even the sketching, it's amazing. Determine the equation of the axis of symmetry of h that has a negative gradient. So yeah, when they speak of the equation of the axis of symmetry of h that has a negative gradient, what they're referring to is, what you want to remember is your hyperbola, right, has two curves. So you have a curve here, you have a curve here, you have asymptotes there, another asymptote, you know, one asymptote, another one. So you have two axes of symmetry. You have one that's a positive, that has a positive gradient, and then it passes the middle, you know, the point where your asymptotes meet. This is the line of symmetry that has a positive gradient. And then you have another line of symmetry that has a negative gradient. See, negative. So they are asking for the equation of the line of symmetry that has a negative gradient. Now, automatically that equation always is y is equal to -x plus c. See, always having a gradient of -1. That's like a law. Now, the idea is you need to find a value for c. To find a value for c, you need a coordinate that the graph passes through. A coordinate that the graph passes through will always be the point where the asymptotes meet. So you already know if this is the x asymptote, you see its equation is x is equal to 1. The y asymptote, its equation is already y is equal to 2. So you already know that this point is 1, coordinate 2. You see, because the x value there is a 1, the y value there is a 2. So you see, this is an x value, this is a y value, which you can throw in there. So y here is a 2, x is a 1 plus c. See, gradient, you have it. It's always a negative 1. X is a 1 here because of the coordinate. Y is a 2. So here 2 plus 3. 2 plus 1, when 2 plus 1 is 3. Yeah, so that's the negative gradient that they are looking for here. If they had asked for the positive gradient, then you would have just said y is equal to positive 1 plus c. And then you would have said whatever, you would have subbed in your coordinate, what. For the negative one, it's y is equal to negative x plus c. Anyways, how many marks is that? 2 marks. You see, just cheap 2 marks. You get them, you move on, you run. For 4 marks now, they want you to sketch the graph of h, showing the asymptotes and the intercepts with the axis. So you see in the course, we cover extensively how to draw all graphs and what you need to show. So here, x-axis, y-axis. Put the asymptotes first. So it's x is equal to positive 1. You see, you don't necessarily need a scale, but your thing needs to be proportional. So let's label here 1. This, let's label it 2, because that's the equation of the other asymptote. So here we know this is the center of our, this is the point where our asymptotes meet. This negative value here tells you where your curves should go, because if that is a negative, your curves need to go there and there. If this number was a positive, then your curves would go there and there. You see, this is for if a is a positive. You see, this is if a is negative. You see, if a is a negative, you do it like this. If a is a positive, you do it like that. Like here, you see, our a value is a negative, so our curve automatically needs to go there. Our curve automatically needs to go there. It does it? Yes. I kind of paused for a bit. I was like, what? Really? Yes. So what we need to do now is, for our 4 marks, we need to show what is the y-intercept. We need to show what is the x-intercept. To do that, we can just use our equation. You see, for the x-intercept, we can make y as 0. Let's do that quickly. And then the -2 goes over. It's like -3 over x minus 1. Then you have -2x minus 1 here, and then that's -3, -2x plus 2. And then here you have, let's take the 2x over. Let's take this one over. That's like 2x. That's like 5. That's like x is equal to 5 over 2. So here we know that this x value is 5 over 2. That's like 2.5. So that's fine. So here we got the x-intercept by making y 0. So let's get the x-intercept by making, now let's get the y-intercept by making x 0. So in our equation, let's make x as 0 now. So we have y is equal to -3, 0 minus 1 plus 2. This is +3 plus 2, that's like a 5. So you label it 5 here. See, all that matters is the labeling. If you can label, you see 5, 2, 1, 5 over 2, you're safe. You will get all your marks. You will not be penalized. You will get your marks. You don't have to put, you see, line. You don't have to do those funny things by throwing a scale or whatever. No, your shape just needs to be proportional. So yeah, I think here we did good. Let's move on to the other portion of question number 4. So 4.2 is a totally different question, like totally different question. So whatever we did previously, at this point in time, it honestly doesn't matter because this is your question. It says that the graphs of this is a parabola. It is in well, we can refer to this as what can we refer to it as? Completed square format. Yeah, that's what I like to call it, because we can clearly see that this is the x value of the turning point, the opposite value. So it's the x value of the turning point is a -5, and the y value of the turning point is a +8. That we automatically know because of what's in our equation. And then this is an equation of a straight line. You see, so you see all the basics that you need to know, including all the difficult questions and how to answer them on functions. You will find those in the functions and graphs course, which I have on Teachable, and the course is in the description, right? So basically all the courses that I make, that's where you can find them. Yeah, they are somewhat comprehensive, you know, multiple examples, and they go deep. Anyways, here with this information, these two graphs, they said A is the turning point. Okay, we have A already because of that information. And then he says the axis of symmetry of F at the axis of symmetry of F intersects the x-axis at E. Okay, and the line G at D. Okay, then he says C is the y-intercept of F and G. C is the y-intercept of F and G. Okay, so they both share this point. So come on, motorbike, come on, I'm trying to record here, you know, for the class of 20 something. But anyways, rude interruption. But anyways, yeah, so this is 9/2 because we know that's the y-intercept of the straight line. We already know what this value is because it's the turning point, so it's -5 and -8. You take this as it is, you change that one. So you see all this information, take note of it. You don't have to fill it all out immediately, but you know, because they'll obviously ask for it. Like here, 4.2.1. I mean, look, they're asking for the coordinates of A for 2 marks only. So you give them 4.2.1, you give them the coordinates. What are the coordinates of A? No, -5/8, we say -5 and -8. Whew, yeah, then I must chill before I make silly mistakes again. But anyways, let's carry on here. The next one says determine the range of F. So F is a parabola. The range starts here. This graph is starting from negative, well, not starting from, but because range asks you where do you see the graph on the Cartesian plane if you look from top to bottom. If we look from top to bottom along the x-axis, we see the graph everywhere until where the y value is a -8, you see. So the range here, we will have to say, let's say here 4.2.2, we have to say our y values clearly need to be bigger or equal to -8, you see. Y values need to be bigger or equal to -8. You could have said, you see, this is option 1, #1. Number 1 option. Okay. Another option, you could have written it as x is a, no, y, it's range. Y is an element of -8 going all the way to infinity, like that. You could have put it like this. This is option number 2. You see, option number 2. You can write it like this, you can write it like this. Because you see, all we said was range, you trace the x-axis and you say, where am I going to see the graph? You see, you're seeing it everywhere. You see, it's going there, it's going to go down, and then it goes up again. So it has all these y values until -8, where -8 is included. That's why we put this number there. That's why we make this a square bracket. So they give us our 1 mark. And then for 3 marks, they said we should get M. Well, I mean, no, we should get D, technically, because they said we should get M and N. M and N. Stop it. We should get D, technically, because M is the X value of D, N is the Y value of D. Now, for 3 marks, you may be asking yourself, what do we do to get M? Do we need a calculation for it? No. What I mean is, this X value is -5, so this X value of E is automatically going to be -5. This X value of D is automatically going to be -5 because our sketch is giving us that information. So automatically you can just say M is -5, you'll get your marks because it's not a calculation question. It's all in your sketch. I should put this next to each other. I mean, like, come on, seriously. So N is a, well, I mean, look at N. N is the easier one to get because N is a point on the straight line graph. You see, with your functions questions, you have everything, you know. Functions questions have an inferiority complex, trust me. So here we said our x value is a -5, our y value is n. You see, x and y. So we can sub in the y value in our straight line graph and the x value in our straight line graph, you see. So here in our equation for g, I mean, technically we already said our y value is just n, and then our x value is -5, and then plus 9/2. I'm wondering why they made this a 3-mark question. They could have made this a 2-mark question. That would not have been too stingy, but I guess they were being very generous in this paper. I mean, let's be honest, guys. I don't want to lie, but a few questions into this paper. Yeah, it was cake, eh? It was pretty simple. I won't lie. Most people say, yeah, the papers get harder as the years progress, but let's not lie, guys. Class of 2020, this was an easy paper. But I may just be speaking too soon. Let's see what the other questions will look like. So n here is clearly a 2, which is fine. So you got n, you get the value, you move on, you don't worry about it. So here it says calculate the area of OCD. OCD is an area. OCDE. OCDE. Getting the area here, I mean, why bother? Just cut it into shapes. Cut it. So you see here we know that this distance here is a 2 because you see from here to there that's a 2. From here to there, technically that's 5 units. You see, from here to there, that's 9 over 2 units. Let's see what 9 over 2 is. 9 over 2 is 4.5, you see. So, you see, let me actually draw the sketch here because, you know, most people don't like what I was doing, I think, the way I'm doing it. Because it's like, why you gotta do it like that, bro? Just make it make sense. Okay, fine, hold on. So, we have this portion. This is 2. So, here we have D, E. This is 2 units. And then you have this here. This is 5 units. From O to E because it's, here is 0. That's -5. So that's 5 units. And then going up to the y-intercept, that's 4.5 in total. So you see, because that's 9 over 2. So what we know is this whole thing here, this is going to be a 2, right? So this automatically has to be 2.5. So the area of the full thing, I mean, let's just do it bit by bit. I mean, half base, which is the 5 here for this triangle, times height, which is 2.5. So we have half times the base times the height. That's 6.25. So 6.25. So here you can label this, that's like BC. BC. There's no letter here. Oopsie, you don't have to label it anything. You can just leave it. The bottom portion is just length times breadth, you see. Length times breadth, which is just 10. Therefore, the area of OCDE, as they said, is going to be 6.25 plus 10, which is 16.25. Very simple. You may be asking yourself, why didn't you write formulas? Well, you can if you want. Half base times height is the area of the triangle. And then length times breadth is the area of the rectangle down there. And don't worry about how I'm putting pictures. This is perfectly fine. Your math examiners really don't watch. They really don't. Yeah, this is perfect. You know, you'll get all your marks here. Don't overthink it because it's just 3 marks as well. Here they say determine the equation of the inverse of G. See, determine the equation of this thing here. Whenever I see this, I automatically read inverse because what else are you going to say? G to the power of -1. Come on now. No. Say the inverse of G, okay? It says here, so you want to read determine the equation of the inverse of G. You see, determine the equation of the inverse of G in the form Y. G is a straight line. I mean, if you're going to get the inverse of G, so 4.2.5, the first thing you want to do is let's write down the straight line. I mean, in terms of y is equal to 1 over 2x plus 9 over 2. So if you're going to perform inverse, I always say x becomes y becomes x. That's what I always do. So let's swap them around, right? This is now x, this is now y. And then they said you should put it in terms of y. So we've performed inverse. This is perfect. This will get you at least, 1 mark. But then they want y to be the subject of the formula. So the 9 over 2 has to go over. And then here you may be thinking, what are you going to do next? Are you going to divide by 1/2? Yes. So here, well, let me not do that. Let me do what most people would have wanted to see. Let's put that over 2 so that I can times by 2 here. And then this whole thing here times by 2 as well. Times by 2, times by 2. This is going to be 2x minus 18 over 2 equals to y. Therefore, y is equal to 2x minus 9. Yep, that's inverse for you. You do that, they give you the marks. How many marks they give you? as many as you want, really. These guys are very generous. They will always give you as many marks as your heart desires, because yeah, it be like that sometimes. They are not stingy. So let's move on to the next question so that we do not waste any time. Let's see here. If h, you see h here is, where is h? There's no h. So you see, if they're talking about h and there's no h anywhere, they are referring to a new graph. They said if h is the inverse of g plus k. So what this means is h is the inverse of g, which is this equation here, right? And k is going to be moving the graph up or down. That's what this does. You see, they said this is a tangent to f. Okay, it's a tangent to f. Determine the coordinates of the point of contact between h and f. Well, I think that's pretty simple, because if h is the inverse of g, firstly the inverse of g would this is going to be a bit tricky, but let's draw the inverse line. I just want to show you what it would look like. Let's do this here. Okay, so getting the inverse, let's see what this coordinate would be. This would be like 0 coordinate 9/2, and then this coordinate would be like I don't know what it is. What's the x value? We don't know. Man, that's not fair. So let's not draw that, and let's just leave it alone then. So in terms of our inverse, whatever, this is the inverse line, by the way. Let's just leave that there. I thought I was going to draw the graph of g, but I don't think that's necessary. Let's just leave it. Let's just leave it. Let me, okay, I can't. So the inverse of this line would somewhat look like, let's see, it would pass 9/2 and 0, so it would pass somewhere there, and then it would pass let's see, somewhere down here, and then it would go something like that. See, this is what the inverse would look like. Yeah, funny enough, because you see, look at this equation, 2x minus 9. So you see, somewhere down here it is going to be like minus 9, and the equation here is y is equal to 2x minus 9. So this is the inverse. Oh, minus 9, come on now. This is the inverse. They say this inverse, if you move it, you see, if you move it a certain number of units, it is eventually going to be, what is it going to be? It is going to be a tangent to this graph of f. So you see, they say g is h rather is the inverse of g. If you move it a certain number of units, it will be a tangent to f. You see, h is the inverse of g plus k. This equation, whatever it is a tangent to f. It will only be a tangent to f if k is a specific number, meaning it will only be a tangent to f if you move g a certain number of units upwards. You see, if you move g upwards, you see, the y-intercept will be increasing. The y-intercept is what will be changing. So, because that's what k will do. K will affect the value of the y-intercept. So they're basically asking you, what does this, well, technically we need to find out what the value of k will be for our line to be a tangent to our curve. So I know, yeah, it sounds like a lot of gibberish, but I hope not. But last questions are always like that, you see. H is this equation, it is a tangent to f. Determine the coordinates of the point of contact between h and f. So the good news is, where a tangent is going to meet f, you see, here we have tangent, and then here you have f, which is curve. So if you have gone through the course, then you already know that a tangent and a curve will always have the same gradient. They will always have the same gradient and the same coordinate at the point where they meet. These are the two big things that they share. It's E, man, coordinate, you see. So what we need to do is, for us to find the coordinate that they meet, we can use the gradient that they share. If you want a gradient, you can use the coordinate. If you want the coordinate, you can use the gradient. Now what we know is our tangent here, whatever this tangent is going to be, you see, it's just the graph of g moved. So our tangent is automatically going to have a gradient of positive 2. So we want to find out the point where our tangent is going to meet our curve. The curve will need to have a gradient of positive 2 as well, you see. So the gradient here, we said it is positive 2, and this gradient is the same for f, and it is the same for h. So for us to find a point where our tangent is going to meet our curve, let's find out which point on our curve is the gradient equal to 2. We don't have to worry about k. K is, we already said what k does. K is just them telling us that for this to be a tangent, the graph of g, which is as in the inverse of g, would need to have been moved up a certain number of units. That's what k is basically doing there. So here we said for us to get the point where they meet, we need to work out where the gradient of this curve is a 2. And yeah, I'm wasting time on this question. Let's just work out where the gradient is a 2. For us to work out where our graph of f has a gradient of positive 2, well, you have guessed it. You see, if you're going to work out where this curve or this parabola, if you're going to work out where it has a gradient of positive 2, then you need to differentiate that equation so that you can get a gradient equation for that graph. Before you can differentiate this, you have to simplify it. You see, we're not differentiating yet. We are simplifying, because in grade 12, you cannot differentiate this immediately. And you can't use other laws that are not in grade 12, like the chain rule or whatever. If you don't know what that is, perfect. Because if you're in grade 12, you don't need to. And you see, I'm messing up here. Talking too much. So we have a half out here. Come on. This is so irritating. Okay, x times x is x squared. X times 5 is like 5x. 5 times x is another 5x. 5 times 5 is 25. Why am I putting square and round brackets? Mixing it up. Don't mix. Be uniform. So now I can put x squared here plus 10x plus 25 minus 8. I can multiply the half inside. It's going to be like a half x squared. This you can say a half times 10 is like 5. 25 times a half, you can put 25 over 2. Remember, use your calculator if you need to. And then here we just have a half x squared plus 5x. And then 25 over 2, you are removing 8. So you can do that in the calculator. That's like 9 over 2. Ooh, haha, plus 9 over 2. Okay. Well, this is expected because, the y-intercept here, you see it's 9 over 2. So we've just simplified our equation, put it in a format that we can differentiate. So here, now we can differentiate. And because we've differentiated, we have put this symbol there. So this is like x, a half times 2 is like 1. So it's 1 there. And then 2 minus 1 is 1 up there. And then plus 5, because 1 times 5 is 5. X, and then 1 minus 1 goes away. Differentiating a constant, it just falls away. So here we have a gradient equation for the curve. We want the gradient, we want the point where the gradient is equal to 2. So here this is giving us the x value where the gradient is a 2. So we're seeing that the gradient is going to be a 2 where x is a negative, ooh, really? Where x is a negative 3. Okay, that's fine. So we have the x value where the gradient is a negative 2. So clearly we want the y value where the gradient is a negative. No. We have the point where the gradient is a 2. That point is x is negative 3. See, this x value is negative 3. It's telling us that the gradient of the graph at negative 3 is a 2. So this is a point where our tangent is going to touch our curve, because they'll touch each other at the point where their gradients are the same. You see, the gradient is a 2 where x is negative 3. So because we now know that the gradient is a 2 where x is negative 3, what we need to do is we just need to substitute negative 3 into our original equation to find out what is the y value where x is a negative 3. So to do that, we can just say, you see, in our equation where x is, we want to throw there negative 3. This is negative 3 plus 5 squared minus 8. And then let's throw that on the calculator. 1 over 2. Negative 3 plus 5 squared minus 8. That's like negative 6. Kablemo. Therefore, the point of contact is this coordinate here. You give them that answer and you do the moving on, because with this question, there was really not much to it. It was just, you know, the wording that we needed to understand, because this can only be a tangent if the graph was moved up a certain units. That's what K is talking about, so you don't have to worry about K. And then we said a tangent of the curve will have the same point where the gradient is the same. So let's move on now to question number 5. Question number 5. So with question number 5, I mean, the big idea is we're dealing with an exponential graph here. And just like with all the kinds of graphs for functions, this is definitely there in the course, you know, in the digital course on Teachable, the digital course that I created for functions. So basically what that course does is, it basically, if you're in grade 12 and you feel like you don't know anything about functions, or functions are difficult for you, that's going to be perfect, because it literally goes from simple to very difficult, you know, in terms of explanations on the course and teaching you exactly what you need to know to answer questions like these. Because basically what I do is I basically like take a past paper. I don't go through the past paper. I basically show you the questions, and then we have a tutorial on how to answer those questions, like showing you the basics. And then yeah, it's a totally different format as compared to the channels, because yeah, the channels are good. I mean, the tutorials are perfect. The course is where things go deep, you know. So yeah, you can check that out. The link is in the description. It says here the graph of f of x is this thing here. Yeah, this is the graph of f of x. It is sketched below. Very nice. Another simple graph. Whew, these guys were very nice in this paper. It says here A is the y-intercept of f. A is the y-intercept of f, yes. B is a point of intersection with the line y is equal to 9. Okay, interesting. Plane sketch, interesting. So they want us to get the coordinates of A. Whew, yeah, these guys, yo, they were being so nice. Sure. Let me not judge. I'm happy that this is how the paper was. So the x value here, we know they want us to get the coordinates of A. Automatically, we know that the x values are 0. That's automatic. We know it. We can see it. The x values are 0, because that way x is increasing, here x is 0. So if the x values are 0, we can throw that into the equation. So here we have 3, negative 0, negative 0. Wow, that's interesting. So here this is saying if the x values are 0, if the x value is a 0, the y value is a 1. Can even put this in the calculator. I mean, it doesn't matter if it's negative 0, it's just 0. You see. So here this is A, 0 coordinate 1. Determine the coordinates of B. Okay, well B, or technically, I mean, look, the x values, we don't know what it is, but the y value is a 9, because if this is 9, I mean, there is also going to be a 9. B is a point on the exponential graph. So for 3 marks, what a wow. Yeah. So because technically, I mean, B, we don't know what the x value is, but we know the y value is a 9. So it just means in our equation, let's put here 5.2. I mean, y value is a 9. So let's say here f of x is equal to 3 negative x. So y value is a 9. And then technically, oh, okay. No, x. I'm sorry, this x. It's x, I promise. So solving for x here, you have to use logs. So you isolate the exponent, then here you say log. The base is 3. The value here is a 9. And then you just put this in the calculator. Laton sin what we're getting here. Tell us calculator. Oh, why is calculator? Tell us the answer. We wait on you. But you have to divide by negative. X is a negative 2. You see, that kind of makes sense, because if you put a negative 2 here, it's 3 squared. X is a negative 2. That's perfect, which makes sense because you see this is on the negative side of the Cartesian plane. So B here, negative 2 and 9. And you see we're using things that we know about our functions and stuff. They say here, write down the domain of the inverse of f for 2 marks. Okay. So quickly, the inverse of f, you have to remember that. Firstly, let's draw the line of inverse. This is the line of inverse. Y is equal to x. Now the inverse of this exponential graph will, oh, I feel like I have shot myself in the foot. Oh no. I think it'll go like that. Yeah, it'll go like this. Yeah, it definitely will. So let me put this point here. If this is 0 coordinate 1, this point here would be 1 coordinate 0, and then it would go like that, you see. And then it would go like this. Draw the curve. Ah, come on, let me just draw the curve because this paper is moving. Stop moving, paper, goodness. Arr. Hey, yeah, it's fine, I tried. So this is what the inverse of f is going to look like. You see, it's a mirror image of each other. See that point mirrored there somewhere. So this is the inverse of f. This is what it would look like. That was not necessary, I guess. But anyways, they said write down the domain of the inverse of f. So if you look at this, the domain here, you can see that the x values need to be bigger than 0. You see, your x values need to be bigger than 0. So that's the domain here. Let me write it out and then show you another way we could have worked that out. X needs to be bigger than, what does x need to be bigger than 0? Now the reason for that is, with inverse, right? Firstly, with inverse, the original graph and the inverse, everything swaps. Meaning the range of the original one, if you think of the range of this graph, you see the range of this graph, right, is technically y has to be bigger than 0. Y has to be bigger than 0. You see. So if the range is y is bigger than 0, the domain of the inverse is going to be x is bigger than 0. So that one may seem a bit funny because inverse, everything swaps. The range swaps, the domain swaps, the x value swap, everything swaps. Meaning where x would be in one of the graph, the other one, there would be y there, vice versa. So the range of the original graph is the domain of the inverse. The domain of the inverse is the range of the original one. And obviously the domain of the original one is the inverse, is the range of the inverse. So just keep that in mind. And you see all these things, imagine, in the course covered everything bit by bit from the beginning, almost pretending as though you have never heard these words before. That's what the course is all about. Yeah. So here it says describe the translation describe the translation of f to become this. So what we can do for ourselves at 5.4, we need to first let's look at what f of x looks like. Always start from what you have. Don't overcomplicate anything. Always start off with what you have. Like here we have x to the power of 3 to the power of negative x. That's what we're starting off with. Now technically what you want to think to yourself is, okay, how do you go from this to that? The first thing to do is, let's try and rewrite this. F of x, because it has a negative exponent, it is exactly the same as 1 over 3 to the power of x. So now when you're comparing these two, what h of x is here and what f of x is. If they're going to ask you what is the transformation, you see, describe the translation. So they're basically asking you what has happened to the graph of f for it to become the graph of what? Of g. So the best thing to go about it is you want to take h, right? Let's take h here. H of x is equal to 27 over 3 to the power of x. What you want to do is, well, here you may be thinking, why can we not just say that? You may be thinking, why can we not just say that the graph of g was multiplied by 27 or something? Yeah, we cannot just say that because they said they want us to describe the translation, meaning they want us to link this to a movement. So in terms of linking this to a movement, the one thing that we can play around with is x, because if we can write this in such a way that we see that there's a shift from left to right, that will be good. Now the fishy thing here is obviously 27 can be written as 3 to the power of 3. And then at the bottom we still just have what we have. So what we're doing is we're trying to manipulate this until we have something that can show us a shift of some kind. So here it's 3 to the power of x and 3 to the power of 3 and 3 to the power of x. Now obviously this, I mean, if your bases are the same and you're dividing, you can minus the exponents. You see, your bases are the same, so you can minus the exponents. So you see, this is the graph of h. So you can clearly now check what has happened to the graph. So the easiest way I can say is try and have your x as a positive value. So let's put here, let me take out negative as a common factor. So you have a x plus 3, and then this is what you have. Well, actually, yeah, you may be asking yourself, what am I doing? Why are you doing it like this? Why are you, you know, I can understand if you have, like, you know, a lot of questions in your head and all sorts of things. It's understandable. So the reason for doing this is so that this negative, you cannot ignore it. You know, you don't want to ignore it. So it's technically 3 to the power of negative 1, the whole thing to the power of x plus 3. And then this is just a third. You see, a third here, and then x plus 3. So now we can somewhat describe what has happened to our beloved graph of f. So don't freak out, right? Because the next thing that we're going to do is quite, we want to link this to that. So what you can do is, I mean, 1 is to the power of this exponent, and then 3 is also to the power of this exponent because of your exponential laws. Now we know that with all math, 1 to the power of anything is always 1. So the top part is automatically just 1, regardless of whatever your x value is, regardless. So the top stays 1. Then here we have 3x plus 3. 3 to the power of x plus 3. Now we can clearly see, okay, this is the graph of h, this is the graph of g. And you can make the comparison now. You see, there's 1 at the top there, there's 1 at the top. There's 3 at the base here, 3 at the base. The exponent here is x, the exponent here is x plus 3. So you see, this shift, we can see it's apparent now. The graph of h is just the graph of f shifted 3 units to, whoa, wait, let's see here. Let me look nicely. Spotted my error. This is supposed to be a negative, you see, because if I swap these two, that's fine. But if I take out a negative, this has to be a negative 3, negative 3, negative 3, and then negative 3. Yeah, I could smell something was off. And then here negative 3. Wow, my first error. That's so annoying. Let me just write it nicely. 1 over 3x minus 3. This is what h of x is. So this is clearly a shift 3 units to the right. So f of x was moved 3 units to the right because it's there. Whew. Okay, that escalated quickly, but this is what this is. We can now move on to the next question. This was how many marks? It was out of 3, and clearly it was a bit lengthy. So if this was not your cup of tea, then it was best to just move on and come back to it later. But this is what we did for 5.4. So now we need to move on to 5. Whoa. 5 point what? We need to move on to 5.5. It says, determine the values of x for which h of x is smaller than 1. Okay, so we need to picture what h of x is first. We can use this. H of x is just our graph of f moved 3 units to the right, like we said. So if this is like a negative 2, we already know this x value is a negative 2. So if your graph is, and you might be wondering, why am I using this as a point of reference? Well, we can use this here and this point to try and picture what our graph would look like if it was moved 3 units to the right. So let's keep that in mind. If this graph was moved 3 units to the right, firstly let's picture g before we answer this question. So if it was moved 3 units to the right, it would now, let's say, you see, it would move 1, 2 units, 3 units. So it would at least be passing there now, where this is, say, like a positive 1. And then if this is 0, it would go 1, 2, 3 units. So it would let's say have that point would be somewhere there, and then obviously I mean it would still just be an exponential graph. It would still be curving. This is not an asymptote, no, so it would still pass that point, but then the point is here, G would curve like that, and then it would pass that point. If it doesn't here, let's just pretend it passes. It will. My sketch is just not very good, and I'm like trying to hold the the camera, and like my hand is like but anyways, that looks horrible. But yeah, this is a curve. Let's just this is our exponential graph. You see, it was moved 3 units to the left. Don't mind how this is not very curvy here. It's too flat. Oopsie, my bad. Wrong words. Let's see. Yeah, there. But anyways, so this is what the graph of h of x would look like. H of x. Now with this graph of h of x, the big idea is they're saying where is it below 0? No, where is it below 1? Yeah. So you see here, this is asking you where is the graph of h below 1, meaning they're asking you, see this h represents y values of h. So this question is asking you where are the y values of h below 1. So if you're going to find out where the y values of h are below 1, you firstly need to find out where are they equal to 1. So we need to find out where is our graph equal to 1, like where are the y values equal to 1. You see, where are they equal to 1, so that we can show that the graph is below 1 at whatever this x value is until positive infinity technically. So to answer this question, it actually looks like we don't need to do any calculations, because, well, I think it may be best if we do calculations. I think it will put everyone at ease, because we as people like calculations, but I don't really think we need to. But it's fine. It's fine. It's fine. Let's just do the calculation so that everyone is happy. So what we said is, if you're going to work out where the graph is below 1, you want to find out where is it equal to 1 to begin with, you see. So your graph of h of x, well, let's just work it out as an inequality. Or let's just do that, because we are somewhat complicating things here. Where h of x is, let's just put the equation of h of x. 3x smaller than 1. So here you can multiply by 3 to the power of x on both sides. Then this goes away, and then you have 27 smaller than 3 to the power of x. Then this is 3 to the power of 3 smaller than 3 to the power of x. Drop the bases, we have that here. So you see x needs to be bigger than 3. That's your answer. This will be good enough, because you see your sketch here is telling you that, I mean, if you move the graph 3 units to the right, your graph will be equal to 1 here, because it's equal to 1 here. So if you move it 3 units to the right, it's still going to be equal to 1 here. And because this x value is 0, if you move it 3 units to the right, this x value is 3. So the graph is below 1. You see, it's going to be having y values that are below 1 from where x is bigger than 3. So that's why that's a 3-mark question. That's perfectly fine. Now we can move on to question number 6. Financial math. Yep, this is, one of those topics as well in grade 12 that are not everyone's cup of tea. So yeah, definitely keep a lookout for a course on this as well. If it's already there, then the link is definitely in the description. Anyways, yeah, a link on, like a course on financial maths and everything. So yeah, but the main emphasis in terms of courses is definitely the functions and graphs, because it's paper 1, so that's like the big deal. The next big deal is like, number patterns, and then financial maths. But anyways, here we are. It says on 31 January, Tsepo deposited, on 31 January 2020, Tsepo made the first of his monthly deposits, of 1,000 Rand into a savings account. He continues to make monthly deposits of 1,000 at the end of each month up to 31 January 2032. And then it says here the interest rate was fixed at 7.5% compounded monthly. For 4 marks, they said, what will the investment be worth after the last deposit? So this is the base. This looks like a basic F formula question, future value annuities. So with this future value annuities question, the first thing is they said, okay, let's just write down that formula. What question is this? Question number 6 in this 2020 grade 12 mathematics paper 2 November memo from the final exam. Why did I have to make it so dramatic? So with a future value annuities formula, F is equal to X. How am I guessing when I can just look at the formula sheet? Yep, don't guess. Use the formula sheet. Use it. So yeah, let's just put our 2 brackets, X and then 1 plus I to the power of positive n minus 1, the whole thing over I. Perfecto. Okay, so this being said, or this being done rather, they said we need to work out what is the value of his investment after the last payment. Now, I mean, if you think of it, right, from the 31st of January 2020 to the 31st of January 2032, this is what you can think to yourself. Just look at the idea from like 1 year standpoint first. So it's like 31 January, let's say here 31 Jan 2020. So he made his first payment. So it's like January, right, to the 31st. Let's say January, Feb, March, April, May, June, July, August, September, October, November, December. So you see January, Jan, Feb, March, April, May, June, July, August, September, October, November, December. You see 31 December, he also made a payment. So let's see how many payments there are in a year. I mean, this is weird, but 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 payments. You see, that's 12 payments. This is in the year. Let's say here 12 payments for 2020 because I was making at the end of every month. So technically, let's think of 2020, right? And then there's 2022 going on and on and on until 2032. So let's check what happens in the year 2032. Let's do the year 2031. Sorry, 2031. In the year 2031, you'll see why I'm doing this. In the year 2031, technically he made a payment on the 31st of January 2031. He made a payment here. This is January, Feb, March, April, May, June, July, August, September, October, November, December. So if you look closely here, do you see that 2031, technically he made 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 payments until 31 December 2031. So technically on the 31st of January 2032, if he made a payment here, that's 1 payment. So let's look at our question to make sense of why I've done all that I've done. They said on January 2020, Tsepo made the first of his monthly deposits of 1,000 Rand into a savings account. He continues to make monthly deposits of 1,000 Rand at the end of each month up till 31 January 2032. So you see, he continues to make monthly deposits of this much at the end of each month up till 31 January 2032. The investment was fixed at 7.5% per annum, compounded monthly. So technically, if you check, right, from 2020 until 2031, you need to recognize that it is 12 years. And this is what I mean. Whenever you want to work out the difference between years, don't just say this minus that. That's wrong. So what I mean is, from January 2020 to January 2031, if you think of it, right, you technically have 2031 minus 2020. You always add 1. let's see what this is giving us. 2031 minus 2020 and then plus 1. That's like 12 years in total. Now you may be asking, what? No ways. So if you look at it, you see 2020, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, and then 2031. You see, say this is January for each year, and then this is January in 2031. You see how many years it's been? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 years. You see, so that means there are 12 years for 12 payments for 2020, 12 years for the next one, 12 months for 2020, 12 months for 2021, 12 months, you see, as in 12 payments for January until the end of 2031. You see, 12 payments each year until this year, you see. So it's 12 payments times 12 payments so far, you see. In 2031, at the end of the year, it has been 12 years times 12 payments that have been made, right? Which is 144 payments. And then in January 2031, we see that he made another payment. You see, that's what they're saying here. He continues to make monthly deposits of 1,000 at the end of each month up until 31 January 2032. So 31 January 2032, he made another payment. So you see, it's going to be 144 payments plus 1, which is 145 payments. Whew! Yeah, this question was brutal. So you see, that's what we need to remember about questions like this. Don't take things at face value. No. From January 2020 until January 2031, these are 12 years. This is a full year, you see. And then all the way until here, that's another full year. And the distance between these two, it's like 12 full years, you see, because we proved it here. There's January 2020, there's this year, then there's 2021, going on until 2031. We have shown that these are 12 years. You see, 12 years of 12 full payments. And then January the 31st in 2032, they made another payment. So it's 12 times 12, which is 144, plus 1, which is 145. Whew, I think that was all worth it. So in our question, right, our F, we don't know, but then our monthly installments, we know it's 1,000. Our value for N, we worked it out to be 145. And then our value for interest, they told us that the interest is 7.5% per annum. So I usually like to put 7.5 and then I write the percentage symbol. Me writing the percentage symbol means I don't have to put this number over 100 because the percentage symbol is doing that for me. But because it's compounded monthly, I can write it over 12. You see, so you can write it like this, or you could have put here 7.5 over 100, and then you divide by 12. You see, this would give you 7 over 5 like that, and then times the 12 down here, which would give you, let's check here in the calculator, it's 7.5, you see, 100 here times 12. Let's see what this number is. You see, it's 1 over 60. No, 1 over 160. That's if you see, put this in the calculator. If you put this in the calculator, the way it is, 7.5 shift percent over 12, you see, it's the same number. So don't worry about me putting this like this, like that. So we have N, we have I, we have X, we need F. So technically F is going to be equal to our X value. We said it's 1,000, so this is like 1,000, and then 1 plus interest, which is 7.5% over 12, and we say it's 145 minus 1, and then the whole thing over 7.5% over 12. Okay, let's do this thing. 1,000, and then there is, I'm just putting all this in the calculator, and then let's see here, it's like 1 plus 7.5 shift percent and then 12 here, and then this is to the power of 145 like we said, minus 1, and then here it's like 7.5% over 12. Whew, moment of the truth. It is 200, why am I putting another equal to sign? Let's see here. 234,888. 888 point, yeah, let's make you useful. 0.535326. This is my answer. Yeah, because I'm doing this very early on in the, well, this is literally a few days after the paper was written. So yeah, man, this memo is on fire, because the other two drafts, yeah, it looked like they botched this question. I may even have botched this question, but I doubt. No ways. I think yeah, but let me not be too cocky. Let's just keep quiet. But this is perfectly fine, and if you check the explanation, I think it made all the sense in the world as to why this is our answer. So the next question says, if he makes no further payments but leaves the money in the account, how much will he have in the account in January 2033? So January 2033, you may, for firstly, the first thing is, I mean, let's see here, 6.1.2. 6.1.2. The first thing is that there are no monthly payments. So we need to remember that, let's see here, it's going to be the A formula. Now, with this A formula, technically in the account, we already know what the P value is. It's this amount, 234,888 point. Try not to round off, because, you know, why? Well, this was a final answer, right? So here you could have rounded it off to 2 decimal places, 0.53. For the next one, I would prefer not to use the unrounded off one. And then interest, we know it's still just 7.5%. Now the idea is, you may be thinking to yourself, okay, fine, is this money still being compounded monthly? Yeah, of course. Majimbo gang. So anyways, this is still compounded monthly, and it's for 12 months, because you see it's from technically Feb, March, April, May, June, July, August, September, October, November, December, January. So you see it's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months. Yes, don't be afraid to count. Otherwise, it's going to come back to bite you. You know, you don't want to do that. But anyway, so let's see here. 1 plus, I'm just putting all this in the calculator. 1 plus this number here, 7.5% over 12, the whole thing to the power of 12. That's like 253,123.5398, and then you can round it off, and then it's going to be this number here. If you want to put the rands, knock yourself out. If you didn't put the rands, it's not a big issue. You will still get all your marks. Now for 6.2. You see, it's just a 2-mark question. 6.2 says, Jim bought a new car. Okay, Jim. Must be nice. Jim het 'n nuwe car gekoop. Let's stop there. That's all the Afrikaans I know for today, that's for sure. So with this new car that Jim bought, it is 250,000, and then it says the value of the car depreciated at a rate of 22% per annum annually. Yo, that's a lot. Then it says, yeah, according to the reducing balance method. After how, actually no, that's not that bad. Then it says calculate the value of the, it says here, bought a car, the value of the depreciated, the value of the car depreciated at a rate of 22% per annum, compounded annually. Yeah, at a rate of 22% per annum annually, according to the reducing balance method. How many years will its book value be at this value? So I think I didn't read that nicely, but he bought this car for this much, right? So initially, the car is 250,000. Yeah. And then they are talking about it depreciating at 22% per annum. So this is just 22%. And then they said according to the reducing balance. So the reducing balance is this one. This is what the reducing balance is. After how many years? So we don't know what n is, or how many, yeah, after how many years will the book value? So the amount after, they said it is how many years will it take for it to become 92,537.64. So in our reducing balance formula, we already know that 92,537.64. What did I just do now? Botched it. Sorry. I'm sorry. I wanted to write equal to, and then I don't even know what happened. It was just a glitch. 250,000 is the amount before, the amount after. You see, there's no rule that says A has to be bigger than P or whatever. No. It all depends on what your question is. If they're asking you to, you see, this is the initial value, this is the amount afterwards. So, yeah, that's not a problem. And then here, our interest is 22%. So it's 1 minus, let me do this so that other people can be happy. And then n is what we're looking for. So let's just see here. 250,000. 1 minus this is like 20. You see, playing games. That's very risky. So let's not do that again, please. But this is to the power of n. So here we can divide by 250,000 on both sides. 250,000. This is like 7 over, yeah, let me just double check that number. 1 minus 22 over 100. Yeah, you see, it's 39 over 50 because it's just this number simplified, you see, because look, 78 over 100. You see, it's still 39 over 50. So this is perfectly fine. This is the power of n. This in our calculator, let's see, there, 9 to, why do we don't have to simplify that. Let's just leave it the way it is. 92537 point that over 250,000. So to get n, you leave it on its own, then you say log the base of the exponent, and then this value the way it is, 92,537.64. The whole thing here over 250,000. And then you legit put that all in the calculator, exactly like that. So you see, you press log here, fraction 78, 100, and then 92,537.64 over 250,000. 4. N is 4. That's a very nice number, because you see, that's what rounding off does. If you don't round off, you'll get good numbers. So here n has to be 4. So it says here after how many years. So here we can just say 4 years, because n is in years, because we didn't multiply by 12 or anything. So what is this question? It's 6.2. This is 0.3. Anyways, the next one says Mpo is granted a loan under the following conditions. Okay. Interest rate is this much, compounded monthly. The period of the loan is 6 years. Okay. The monthly repayment on the loan is 1,500. Her first payment is made 1 month after the loan is granted. So them telling you that her first payment is made 1 month after the loan is granted. There are no payments missed here. No missed. No missed payments. There are none, because if you take a loan here today, a month later, and you start paying, you have not missed a payment, because remember, your loan only starts gaining interest 1 month after you have taken it. So here it says her first payment is made 1 month after the loan is granted. So there are no missed payments. Keep that in mind. Then here it says 6.3.1, calculate the value of the loan. So, okay, that's interesting. Because you may be thinking to yourself, okay, I mean, this one is somewhat, let's see, calculate the value of the loan. So whatever loan that was taken, we know that that's the value of P. So let's not overthink anything. 6.3.1. So P is equal to X. 1 minus 1 plus I to the power of negative n, the whole thing over I. And then P is what we're looking for. X is 1,500. Interest, they said it is 11% per annum compounded monthly. So 11% per annum compounded monthly. N is 6 years times 12. So let's see here, 6 times 12. Negative 72 up here. Ooh, so aggressive. And then here we have closed bracket. I forgot a bracket somewhere here. Yeah, here. Ooh, wow, that was going to be horrible. And yes, you spotted that, but I didn't. I'm only spotting it now. Yeah, 1 minus this thing here, that. And the whole thing over 11, that. Okay, let's put all this in the calculator. Let's see, 1,500. And then it's like 1 minus. And then it's like 1 plus 11%. You see, don't forget the percentage symbol if you like to do it the way I do. And then it's negative 72. And then at the bottom we got the 7 point what's the interest again? 11. I'd forgotten. Getting so distracted. Not distracted, I literally got knocked out. I was like, what, where are we? You know, that moment when you're just sitting and you're wondering, where am I? How did I get here? Type of thing. That's the thing what was happening to me. But anyways, yeah, 78,806 point. Why do I keep doing that? Just do this. Yo, like 0.01945. And then to 2 decimal places. Therefore, P is equal to R. That was actually a mistake, but let's finesse it. 78,806.02. Fantastic, fantastic. Good. We move on now then. For 3 marks only, that was fine. How much interest will Mpho pay in total over the 5 years? So they want us to work out how much interest Mpho will pay in total over the 5 years. Over the first 5 years. Okay. So what we need to do to find out how much interest Mpho will pay over the first 5 years is, firstly, we need to work out in. Hold on. No. It's 0.3. Ah, man. My bad. Sorry about that. I forgot the 0.3. Sorry, people. So you see, I think this is going back to why it's important to write down the information before you start, because you see, if when I wrote it down, I would not be in this mess. So let me just re-put all this in the calculator. I actually don't need to re-put it. I just need to go here and put in my values. Let's see here, minus 0.3 there. And then let's see here, 0.3 there. Because yeah, I mean, errors are bound to happen. I won't deny that. So P here is equal to 78,000. 173.49323. 49323, which is therefore P is equal to 78,173. Well, this is technically, I mean, you may be thinking to yourself, what is this if you round it off to 2 decimal places? I mean, it's clearly just 49. I mean, you know, let's not be fancy. But anyways, that's that. Yeah, that was kind of a weird error. But anyways, we were at question 6.3.2. How much interest will Mpho pay in total over the first 5 years? So, to understand questions like these, we have to remember that firstly, the loan, right? We said the loan amount was 78,100 and 173.49. That's what we got. This is the loan amount. This is what they borrowed. So if you're going to work out how much interest will Mpho pay in total over 5 years. So what you want to do is you want to work out the balance on the loan first after 5 years, and we'll explain why just now. So let's work out the balance on the loan after 5 years first. Let's see in 5 years time, how much does she owe? Because if we know how much she is owed, if we know how much she is owing, we can work things out from there. So let's see the balance of the loan in 5 years time after she has made payments for 5 years. So remember, your balance will be equal to A minus F if you are working with the number of payments that have already been made. So A here refers to the compound interest formula. A is equal to 1 plus I to the power of n. F here refers to the future value annuities formula. X 1 plus I, n minus 1 over I. Let's get these two values first. A, P here you will use your normal number, 78,173.49. 1 plus interest is, remember, it's 11.3% compounded monthly, and then this is for 60 payments because it's 5 years, right? Remember, 5 times 12, which is 60. So let's see here what the A value will be. Or is it? Yeah, let's check what the A value will be before we let's just do it. 78173.49. Yeah, financial math is yeah, it beats this one. Doesn't play games, but it's fine. Luckily it's not like a gang load of marks in an exam anyways. So let's see here. This value here is 137,179.0439. And then for the F1, it's gonna be X is 1,500, so it's like 1,500, and then just make sure I don't run out of space here. 11.3% over 12, 60 minus 1, the whole thing over 11.3% over 12. So our F here, yeah, it's a process, né? It's a process. But you see, if they had asked to work out the balance on the loan after 5 years, we would have just done this. But for what they're asking, we need to get the balance on the loan after 5 years first. So let's do it so that we can explain some more. 1 here plus 11.3 shift percent over 12, and then the whole thing to the power of 60. This is 11.3% over 12. Problemo. Okay, 279,526.0787. So our balance, let's see here, balance is going to be this number minus that number. Let's just put it into our calculator. So let me write it out also, like 137,179.0439 minus this number, 279,526.0787. Yeah, let's not make a mistake here. 0.0439 minus 279,526.078. that. Yeah, let's just double check we didn't put any wrong numbers, because that happens, you know, that happens. Oh, I mixed them up. Oops, sorry. Balance. No, hold on. Yep, I knew something was wrong. I don't know what I did, but yeah, see, this can't be. I don't know what I put in the calculator. You probably saw it, but I didn't. So the value of F here is 120234. So don't mind all these mistakes, because remember, I mean, at the end of the day, you're bound to make mistakes. You just need to fix them in an exam. Don't expect your stuff to be like perfect or whatever. Otherwise, you're just, I don't know what you are. But anyways, yeah, so if you see answers are funny, don't just take them, question them. Because obviously here, why are we getting a negative number? It doesn't make sense. So here, let's just try this again one more time. I should have spotted that before I even started putting numbers, because I'm like, what? The one number was bigger than the other one, and it's like, doesn't make sense. But anyways, 3, let's put here 2, let's see here. No, it's 234, and then point, Yeah, you see, I should calm down, chill, bro, chill. I know the talking is, maybe I should pause for a bit, you know, take a breather, cause like, yeah. Okay, 16945.0006. Okay, so this is the balance on the loan after 5 years. Now, if this is the balance on the loan, technically, if you think of it, if you think logically, this is the balance on the loan, you see. Meaning, if he owed this and this is his balance, look at this. 7, 8, this is what he loaned out. This is his balance. So let's check how much he has paid off. That. So we're saying what he took out a loan for, what he has to pay left, what is left to pay. This is going to give us how much he has paid already. This is, let's say how much he has paid off. You see, let's get this number in our calculator first. So it's 78,173.49 minus 16945.1236. So this is how much he has paid off in terms of his loan. He has paid off 61,228.4894. This is how much he has paid off this money. Because remember, every single month your loan gains interest. So every time it gains interest, I mean, you obviously are eventually going to pay way more than this. But anyways, in 5 years' time, he has paid off this much of this loan. But then we know that on top of this money, every month they were putting interest on it. So of this money, he has paid off this much. So that's why he has left to pay this much money. But then when he was paying off this money, to counteract the interest, he was paying 1,500. So technically he was paying 1,500 for 5 years. You see, so he made 60 payments of 1,500. So he made 1,500. He made a payment of 1,500 every month for 5 years. So you see, he has paid 90,000. He paid 90,000 to pay off this debt, because everything else, the difference between this debt and this money is all the interest that he was paying. So 90,000 minus what he paid off his loan is leaving us with everything that went to the interest. So 90,000 minus, I normally don't like to use the ans button, so let's 90,000 minus 61228.48 no, it's not to do funny things here. See, like that, this is giving us that the interest that he paid was 28,771.5106, which is equal to 28,771.51. So you see, that's the idea behind this question. And you can see, you can understand why, oh, it's 4 marks, it's not that much, but this is how much he loaned out, and then after 5 years, this is what he has paid off, because this is balance. This is what he loaned, this is his balance, so it means this is what he paid off already, off this loan. So he paid off this money, but then to pay off this money, he had to make payments of 90,000 rands, because this 90,000 rands minus what he paid off leaves you with all the interest that they charged him for. So that's the idea with this question. Now we can finally move on to question number 7. Question number 7 looks like this. Well, it's a first principles question, so I mean, it's pretty straightforward if you ask me, because with all first principles questions, I mean, we just need to remember our first principles formula. And it's so funny how with all grade 12 papers, every single one since 2014, there's always a first principles question. So I mean, that's always guaranteed marks. But anyways, getting the first principles of this, they said f of x is equal to 2x squared minus 1. So while I was talking, I was writing the things down. So there's f of x, they need us to differentiate using first principles. So all that means is in our, oh, I forgot the limb. Oh, you see what happens when you don't use your formula sheet. Forgot the limb. That limb is important. So let's just drop it in there. And you see the limb comes after the equal to sign. How is it? There. So let's just finish this. Limb h goes to 0, and then put the equal here. So here we need to, this is telling us that in our equation of f of x, where x is, we should put x plus h. So let's do that. Lim h goes to 0. Where x is, we should put x plus h. That's what this thing is telling us. Let's do here 2x plus h squared minus 1. And then minus f of x, meaning we're minusing that whole thing here. 2x squared minus 1, the whole thing over h. Weird, right? Because all we did was, in the equation of f of x, this is the equation of f of x. And you see the brackets are very important. This here is saying in the equation of f of x, you see in the brackets here, this is where x would go. So they're saying where x is, throw in this whole thing. So where x is, we threw in that whole thing. Now we just need to simplify. And you're seeing I'm going to have the limb all the way until we're done. So here, don't say x squared plus h squared. It's wrong. Here you need to say x. This is the same bracket twice. So you have that bracket here, then you have it again. This is minus 1 minus 2x squared plus 1, because you're multiplying the negative inside. And then here you just want to stay calm, because I mean, why not? What you could actually do first off is, you know, before you start working this out using first principles, try and, you know, just somewhere put what the answer should be, you know, so that you can always double check when you're done. We should end up with 4x. So anyways, let's carry on here. Here you can have 2, and then x times x, that's like x squared, and then this times that, that's going to give you xh, and then xh again, so it's 2xh. Then h times h is going to be h squared, and then negative, and that, these are going to cancel out because negative 1 and positive 1, so it's like those go away. Minus 2x squared over h. Now for the sake of anyone that's wondering why I did this, so technically we had x plus h, x plus h, so it's x times x, right, which is x squared, x times h, which is xh, x times h, or h times x again, so it's another xh, and then h times h, which is h squared. And then we have 2 of these plus 2xh. Okay, just so that everybody's happy. Anyways, then here we have lim. Please don't be blurry. I mean, we want to see here. Lim h goes to 0. And then we have 2x squared plus 4xh plus 2h squared minus 2x squared. The whole thing over h. This has to cancel that. So you see in your what? Your first principles question, always have things cancelling out at the top. If they're not cancelling out at the top, there's something definitely wrong. And then here we can take out h out, and you see I'm still doing the lim thing because, you know, it is what it is, man. You gotta do this stuff. There's h left here because we took out one h, and then this goes away. Now because you're going to throw in the 0, you're going to have here 4x. You can put 2 0 here, and then 4x. Then you can put this symbol to show that this is your final answer. And if you compare it with what you had here, yep, it definitely checks out. So yeah, first principles question. This is all you had to do. It looks like it was pretty straightforward, and all first principles questions will always be there. There will at least always be one in an exam, so don't lose marks, you know, for stuff like this. Now for the next question. 7.2, they want us to differentiate. So here you see they've put d over dx. They just want you to differentiate. I know it's, yeah, they're making it look funny, but that's what they want you to do here. So differentiating this, well, let's simplify first. So you would want to keep this here. Simplify what's in the brackets. Here the 5 can go under the 2, so you have x 2 over 5, and then plus x to the power of 3. Now when you differentiate this, it is going to be equal to this exponent times 1, so it's 2 over 5x. This exponent minus 1 is going to be negative 3 over 5, and then plus here you're going to have 3 times 1, which is like 3x, and then 3 minus 1 is a 2. Now here you're fine, here you're done. You see, this is 100% your answer. Some memos you'll see they will like to put this as a positive number, meaning what they'll do is they'll take the x with a negative exponent, they'll put it down there, so they'll have 5x to the power of negative 3 over, it's going to be positive now because they've taken it down. And then they will also, if they want, they could even be funky by, there's this 5 here, the big one, they can also take the tiny 5 out, then they'll put like a square root symbol here with x and a 3 there. They can also do this. But then if you ended up here, this is 100% fine. You'll still get all your 3 marks because here they said nothing about leaving your answer as like a positive, with positive exponents or anything. They did not say anything like that. If they did, you could have done this, it's 100% fine. You could have done this, 100% fine. So that's for 3 marks. The next one says differentiate. They say determine the derivative or the first derivative if f of x is equal to this thing here, where x is not equal to 3 over 2, where x is not equal to negative 3 over 2. Okay, well, clearly for this question, if you're also going to differentiate, you have to simplify first. We cannot jump into just differentiating that. Simplifying that, it looks as though we are going to, what's that thing? Yeah, it looks as though we're going to factorize first. Now, you may be thinking, factorize first. Yeah, clearly, because here you see we have a square number minus a square number. The square root of this whole thing is just 2x. The square root of this whole thing is just 3. So this one can have a bracket. This one can have another bracket. You see, because this 2 squared is 4, x squared is x squared. 3 squared is 9, you see. So this is the difference of 2 squares. That's what the difference of 2 squares is, because technically we have the 2x, this thing squared, minus 3, that thing squared. Square number minus square number. That's the difference of 2 squares, and that's for the top. Now at the bottom, you can see 2 can be taken out as a common factor here. Automatically, you see here, this can cancel that, so you have, oopsie. This is going to be tricky. No, it's not actually, it's just 2x minus 3, the whole thing over 2. So this is what f of x is, and you see, I haven't, I just simplified. But anyways, this is just 2x over 2 minus 3 over 2, which is just x minus 3 over 2. So this is f of x, you see? All this is legit just us simplifying. So differentiating this, I mean, if you think of it, differentiating this, it's just going to be 1. Because if you think of it, this, if you differentiate, it's 1 times 1, which is just 1. And then here, differentiating a constant, it just falls away. So that's that for that question. Nothing major, nothing extravagant, nothing difficult. It's all good in the hood. So this is all you had to do. Now, it looks as though we are now going to comfortably move to question number 8. Okay, so this is what question 8 looks like. It looks like an okay. Wow, this question is so standard, like your increase, point of inflection. Wow. Anyways, it says the graph of g of x is this thing. It is a cubic function having y-intercept at 0, and then it is drawn below. Then it says the coordinates of the turning points of g, or rather the x values of the turning points, are at -1 and +2. So yeah, this is the most basic cubic functions question I've seen in a long time. I don't want to lie, but question 8, let's see. It says for which values of x will g increase. So if you have maybe gone through any of the tutorials, you will note that a graph will be increasing, where if you think of a roller coaster, you see here you're going to be going down, 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 down. And then from this point, not including it, until this point, not including it, your graph will be increasing. You see, your roller coaster would be increasing. So your graph is increasing, 8.1. You basically need to say that the graph is increasing. The x value where it will increase is where x is bigger than -1, or where x is smaller than 2. You see, if you want to write it in one line, you can say x needs to be bigger than -1, x needs to be smaller than +2. Another option is you could say x is an element of -1 until +2 with circle brackets, because at -1 and at +2, the graph is neither increasing nor decreasing, because you see the gradient there is a 0. But yeah, so we are not including -1 and +2. We're just saying everything above -1 and everything below +2. Then it says here, write down what do they want to say? Write down the x coordinate of the point of inflection. What? Hey, who set this paper, guys? Such a nice person. Like, let's not lie. This person was being so friendly. Like, what? Hey, get the point of inflection. Okay, that's nice. Of course, let's get it for 2 marks. So remember, your point of inflection is, you see, you may be thinking to yourself, we can differentiate twice and then equate to 0. But you see, you don't have an equation. So what you're gonna do, you see, this is where the tutorials on the main channel help, or the tutorials in the playlists help, because you see, we mentioned that getting the point of inflection, or the x value rather, it is the middle of your 2 x values of your turning points. So the middle of your 2 x values of your turning points is just -1 plus 2 divided by 2. That's a half. So the x value is a 2. So x value is a half. Your point of inflection is where x is a half, because it's in the middle of your midpoints. You see, that's why it's important to know many ways of doing the same thing. Wow, if you watch the tutorials, you're killing it here. I mean, you were having a party, or are having a party, whichever way, because all this is in the tutorials, like everything. And imagine the course, it's all there, guys. It says, for which values of x will g be concaved down? So g is concaved down. So firstly, our point of inflection is somewhere here. This is where x is a half. We need to know where this point of inflection is, because it splits up concavity. So the side that's concave down is the side that's frowning. See, this is the side that's concave down. The side that's concaved up is this side that's smiling. So they want, where's the graph concave down? It's concave down here. So the x values where it's concave down, it is x values that are bigger than a half. So here, 8.3, x values need to be bigger than a half. But anyways, if they say here, this is the first derivative, you see. This is the first derivative. This is g, the original graph. This is the first derivative. They say determine the equation of g if you're given the first derivative. Well, what I would do is I would take the original graph the way it is, and then I would basically differentiate what we are given here. It's going to have variables and everything, but then with this question, it's literally a matter of mixing and matching to get your answers. What I mean is, this is what g of x is, right? And then this is what its first derivative looks like. Its first derivative is negative 6x squared plus 6x plus 12. I was just writing that down. I don't know, I was not showing it, but yeah, you see. So what you want to do is, to get a, b, and c, just mix and match, meaning get your first derivative here. It's going to be 3 times a, which is 3ax squared. 2 times b is 2b, x to the power of 1, and then 1 times c is just c, and then 1 minus 1 is 0, so the x, you won't have to write it. Now if you think of it, we said mix and match. So technically, come on. The -6 goes with 3a, you see. 3a is equal to -6. The 6 goes with 2b. 6 is equal to 2b. The 12 goes with c. That's it. Here, divide by 3, divide by 3. A is equal to -2. Here, divide by 2, divide by 2. B is equal to 3, C is equal to 12. Like I said, guys, like this cubic functions question, people that wrote this paper and like went through the tutorials and studied and all that stuff, y'all had a party. You had a good time. It says here, determine the equation of the tangent to G that has a maximum gradient. Okay, determine the equation of the tangent to G that has a maximum gradient. Okay, write your answer in the form y is equal to mx plus c. So what they mean is we need to get the steepest tangent to this graph possible. Okay, you see, determine the equation of the tangent to G that has the maximum gradient. Write your answer in the form y is equal to mx plus c. So the tangent with the maximum gradient, well, if you think of the way this question is like worded out, right, our tangent clearly has to have a positive gradient. So if our tangent is going to have what you may call what the highest gradient possible, well, technically our gradient would need to be between -1 and +2, because you see, between -1 and +2, that's the only portion where we are going to have positive gradients anyways. But the key thing here with this question is, it seems a bit funny, but it's actually not so bad, because it says determine the equation of the tangent to G that has the maximum gradient. So what you may want to do is firstly get a gradient equation of G, and then find out where that gradient will be a maximum. So I mean, if you think of it, look, for 8.5 we have a gradient equation. It is this one here, this one. This is our gradient equation. G first derivative is equal to -6x squared plus 6x plus 12. This is a gradient equation. Remember, when you want to get the maximum of something, if you want to get the max of something, remember, you always differentiate and equate to 0. You see, so this is a gradient equation. We have a gradient equation already. We want where that gradient equation will be a maximum. So we are going to differentiate it, as this law says, and we're going to equate it to 0. So differentiating this, technically it's going to be your second derivative, which is like -12x plus 6. And then making this equal to 0, you have -12x plus 6. This is like 12x equal to 6. Then it's like divide by 12 on both sides. So your x value is a half. So what this is telling us is your maximum gradient occurs where x is a half. So let me put this here. Max gradient occurs, I don't know how you spell occurs, but let's pretend, occurs where x is equal to a half. So we have a gradient formula here. In this gradient formula, we know that the maximum gradient, we will find it where x is a half. So what we need to do is we need to just take our value for a half, throw it into our gradient formula, and find out what the gradient is there at the point where our gradient is supposed to be a maximum. So here in our gradient equation, we want to find out what is the maximum gradient depending on a specific x value where the gradient is occurring. So they're saying the maximum gradient is occurring where x is a half. So let me just do this. What am I doing? I want to like show that this is like something afterwards. I want to separate them. So the gradient here where x is a half, let's put this all in the calculator. It's just like -6, and then there's like a half, and then there's like square plus 6, and then there's like a half, and then there's like plus 12. Kablamo, 27 over 2. So this is like 27 over 2. So this is the gradient. You see, our straight line graph, whatever the tangent we're working with, the equation of that is y is equal to 27 over 2 plus c. No, x, 27x plus c. So now we need a point that the tangent passes through. Now good news is, you see, the tangent clearly is going to pass where x is a half. So it's going to pass there. So we need to find out what is the y value here where x is a half. So to find out the y value, I mean, we can always use the original equation, you see. So the original equation, we just need to find out what is the y value where x is a half. So in the original equation, let me get this original equation. Let's think here. Where's that original equation? Yeah, a, we said it is -2, so it's like -2, and then it's like a half to the power of 3 plus b, we said it's a 3, so it's like 3, and then a half squared. C, we say it's 12, so it's plus 12, and then a half. This, if you put it all in the calculator, let's see, -2, a half squared, no, cubed, then it's like a third here, then it's like squared here, then it's like a 12 over there, and it's like another 12, no, let's stop it, please. 13 over 2. Okay, so this is 13 over 2. So you see x value, y value. So in our straight line graph, we know that y value is 13 over 2, 27 over 2, x value is a half. C value, let's see here, 27 over 2 times a half, that's like 27 over 4. So here it's going to be 13 over 2 minus 27 over 4. Yeah. Then this is C. Our C value is 13 over 2 minus 27 over 4. -1/4. Therefore, y is equal to, gradient is 27 over 2x minus 1/4. Hectic. Hey, but let's not lie. Hey, the first few questions, yo. I have, honestly speaking, I am not joking, I have never, ever seen, okay, not ever, I think that's too many, that's too much. Out of all the past papers I've looked at, gone through, questions I've gotten or whatever, in the past few years, let's be honest, this was the easiest one ever. 2020, they did you good here. They did you good. This was like a gift from that place up there. So anyways, this is all you had to do for 8.5. Everything else was proper easy. Like, let's not lie, this was one of the easiest questions in this whole paper. Like, yo, must be nice. Moving on to question number 9. So let's see, we're almost done. Well, let's not speak too soon, but anyways, it says a closed rectangular box has to be constructed as follows. So we have a certain box. Well, if they said it's a box, rectangular box, okay, that's fine. They said the length of the base has to be 3 times the width, and the volume is 5 meters cubed. Okay, the material for the top and the bottom parts costs 15 rand per square meter. Okay, material for the bottom and top, okay, 15 rand per meter, and the material for the sides costs 6 rand per square meter. So with all questions like these, we are obviously going to reread it again at some point, but before that though, clearly we have to make a sketch. If you did not make a sketch for this question, yeah, you're a special child, but it's fine, because maybe you did not need it. So with this sketch, let's see here, they said it's a rectangular box, so this is our rectangular box, nice box. And then they said here, let me just put the dotted lines so that it's like, yeah, that's the things. So it says here now, the dimensions, we have length, breadth, and height. So let's see here, well, clearly this is height, height, the length, and the width. Well, let's say length here, let's make this, it actually, funny enough, it doesn't matter what you make the length or what you make the width, it's more or less the same thing anyways. Let's say here length, and then here you have the width. Okay, so here they said the length of the base has to be 3 times the width. Okay, the length of the base has to be 3 times the width. So say the width is x, right? The length of the base has to be 3 times the width. So this bottom portion here, its length has to be 3 times the width. Okay, that's fine. Then it says the volume has to be 5 meters cubed. So the volume has to be 5 meters cubed, meaning the volume, remember, is length times breadth times height. Keep that in mind. But in our case here, you could say the volume is length times height times the width. You know, it's just variables. It's just saying all the dimensions multiplied by each other. Anyways, it says the material for the top and the bottom parts costs 15 rand per square meter, and the material for the sides costs 6 rand per square meter. Show that the total cost to construct the box can be calculated by this. Well, this is not so bad, because the cost is technically going to be the area of the top and the bottom. Let's say here area of top and bottom, technically, plus the area, it's area of the sides. So let's just get the area of the top first and the bottom, and then the area of the sides afterwards. So the area of the top and the bottom, clearly that's like, you know, what is this here? Okay, so they're using W, H, and the length. Well, let's just use their variables. Yeah, let's just do that. The width, let's just label it W. So this is going to be 3W. So the area of the base, if you think of the base, this is what the base looks like. It's 3W here and it's W here. So the area here is length times breadth, right? But we have two of these. So it's like length times breadth times 2. So this is like 3 times 2, that's like 6W squared. Okay, that's the area of the top and the bottom. Okay, this is the area of the top and the bottom. So the area of the sides, well, technically the sides we have to be more careful, because the sides we have this one here that looks like this. We have two of these, and then we have, you see, it's the front and the back, and then we have the sides here. So let's just do this here. Let's just show it like this. So you see the front is like W times H. So it's like W and H here. And then here it's like 3W and H, you see. 3W and H. So the area here is going to be it's going to be 2 times W times H. The area here is going to be 2 times 3W times H, which is technically 2WH plus, let's see here, 2 times 3, that is technically, what is that now? 6, man, 6WH. Wow, okay, this is escalating. And then here, 2WH plus 6WH, that's like 8WH. This is getting interesting. So you see, yeah, dimensions. So let me put here top and bottom. Let me actually label it top, bottom. And then this is front, back. And then this is the left and the right. Left, right. Okay. So we have the area of the top and the bottom. This is the area of the top and the bottom, the full thing. We have the area of the sides, because it's all the sides, the full thing. So we know that so firstly we know that the cost for this, right? Let's say here the cost for this, they said the cost for the top and the bottom is 15 rand per square meter. So here this is going to be 15 rand times the area. So it's 15 rand per square meter. 15 times 6 is going to be 90. So we have 90W squared. So let's say cost, and then here the cost, let's specify the cost for the top and the bottom is this one, and then the cost for the sides, they said it is 6 rand, yeah, per square meter. So it's 6 rand times the area, because this is 8WH square meters, so it's 6 rand per square meter. 6 times 8, I know what it is, but I'm going to check with the calculator, 48WH. So you see the total cost is technically going to be this 90W squared plus this 48WH. Whew, interesting question, but it was okay. Not much of a big deal, that one. determine the width of the box such that the cost of determine the width of the box such that the cost to build the box is a minimum. Okay, so this is easy. So they say determine the width, meaning determine a value for W such that the cost, so using your cost formula, such that the cost will be a minimum. So all you do is, this is the cost formula, right, in terms of W. Let's say here the cost formula in terms of W, it is 90 W squared plus 48 WH. So we have a cost formula. We want to work out a minimum, we want to work out a value for width where the cost is a minimum. So to get a value for width, first we have to differentiate this once, and then we have to equate it to 0. So differentiating once, this is like 180 W plus, you see we're differentiating in terms of W, so this is like 48 H as a coefficient, and then W, yeah, because here you see you want to, let me actually put an arrow here to show that, you see this is like W that plus 48 H W, you see, so that you don't get confused. You see 2 times the 90 gave us this, and then 2 minus 1 is 1, and then here technically 1 times the 48H is 48H, and then 1 minus 1, the W is not there anymore because it's W to the power of 0. So this is differentiated. And then now you may be thinking, oh snap, the H is a problem. So we'll deal with the H now. So making this equal to 0, let's say 180 W plus 48H. Getting a value for W here, this is like negative 48 with H here equal to 180 W. And then, it's not very nice to be seeing a negative value here because our width needs to be a positive number. So yeah, hunzima. It's not happening. It's not looking very pretty. But yeah. Let's just carry on, because you see we need to be careful. We need a value for H afterwards. So let's divide by 180 here. We need a value for H clearly, and we can get a value for H by using the volume that they gave us, because remember we haven't even touched the volume yet. So let's see here, negative 48 over 180. So you see what we're doing here is we're literally going to we're literally just going to carry on with what we're doing, because nothing we've done so far, nothing is wrong. We just need a value for W, but to get that value for W we need H. We need an expression for H, or a value for H. To do that we can use our volume. You see, they told us that volume is equal to length times breadth, length times height times width. But then they said the length is 3 times the width. So here it's like 3 times the width times H times W. This is equal to 5 meters cubed. And then technically what that means is we can get a value for, what can we do? Oh, no, we can get a value for H in terms of W, because look, this is just like 3W squared H and then 5. Divide by 3W squared, divide by 3W squared. This goes away, so H is 3W squared. And here, let's hope we don't have an error here. Let's go back there. So we have negative 4 over 15. Our value for H is like 5 over 3W squared. Oopsie. Looks like we're back to square one, but anyways, negative 20 here over 15 times 3, that's like 45. W squared is equal to W over 1. We can cross multiply. This is like 45 W cubed. Divide by 45. You see, we're just finessing the question as we go, because sometimes it be like that, it be like that sometimes. But let's see, negative 20 divided by 45, that's like negative 4 over 9. That's a cubed number, so I mean this is cubed, so it's fine. That can be a negative, don't worry about it. So shift cube negative 4 over 9. A negative number. Pause. So actually, no, it's fine. What I mean is, what we need to keep in mind here is whatever we've done here nothing is wrong. We just need to make sure that W cannot be a negative. Therefore, W is equal to positive 0.76. Now you may be thinking, wow, dude, are you just forging the question? No. The idea is, if let's say you got a value for H in the beginning, let's say you threw the value for H here, right? This is what would have happened. Let me just show it to you so that we don't fight in the comments, because I'm not keen on fighting in the comments. So let's see. So if you had put your value for H beforehand, you would have gotten 5 over 3 W squared. And then if you simplified here, you would have had this. This, if you times it, 48 times 5, that's like 240 divided by 3. Let me just, this times each other. You would have had 240 W over 3 W squared, like that. And then you would have had 1 W cancelling 1, 240 divided by 3, that's like 80, so you would have had 90 W squared plus 80 over W. And then here you would have had 90 W squared plus 80 W negative 1. When you then, this is just CW, you see, if you then differentiated, you'd have gotten 180 W minus 80 W negative 2, you see. And then here, if you get a 0, you would have had negative 180, you'd have 0 is equal to W minus 80 W negative 2. And then here, well, technically this one you can write it as, that can go under actually. And then here this can go over, it's going to be a positive 80 over W squared. Then you have 180 W over 1. And then if you cross multiply, you have 180 W cubed equal to 80. If you divide by 8 on both sides, you're going to have, let's see, what is 180 divided by 80? 9 over 4. Oh, I have 4 over 9. No. It has to be 80 divided by, 8 divided by 180. So it's like 4 over 9. 4 over 9, you see. And then if you get the cube number of this one, is equal to cube number of that one. W is equal to 0.76. You see? Same thing. Whew, yeah. So that's why W here is 0.76. So the question had said determine the width of the box such that the build will be a minimum. So the width is just 0.76 meters. So that will give you how many marks? 6. So now we can move on to question number 10 after doing all this work. Where does this question start? This is like 9.2. So 9.2 starts here. 9.2. So now let's move on to question number 10. Okay, so the second from last question says, in a certain country, 10-digit telephone numbers with the following format were introduced. So it's a telephone number, they have an area code, they have an exchange code, and then they have the number. So okay, so let's see example of digits. So this one has 3 digits, and then the number, the last portion has 4 values, and then this is an example of a number. So this number is like 901 544 1230. Okay, then it says digits may be repeated. Okay, this is a big thing. Digits may be repeated. So they said how many possible 10-digit telephone numbers could be formed. Well, I mean, for 10.1, the thing is how many possible 10-digit telephone numbers could be formed. So the key thing to remember is that this is fixed. You see, 3 digits, 4 digits. So here you have 1, 2, 3 options. Here you have 1, 2, 3 options. Here you have 1, 2, 3, 4 options. So in this slot, I mean, technically you have 10 numbers. So it's like 10 times 10 times 10. And then, well, in the next slot, it's the same thing, 10 times 10 times 10. And then in the last slot, technically it's also the exact same thing, 10 times 10 times 10. Okay, so this one looks kind of funny because it's just tens everywhere. Times 10, times 10, times 10, times 10, times 10, times 10, times 10. Woo! 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 to the power of 10. Which is 10. It's just like what? I'm just going to use the calculator. Ah, come on. What is this number? Well, it's a big number. I think it's 10 with like what? No, let's count the zeros. 1, 2, 3, 10 zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, I don't think that was necessary, but here we are. This is your answer. And this answer clearly is like what? Is this like 10 billion? 3, 6, 9, yeah, 10 billion. Moving on, 10.2. 10.2, they said there certain restrictions were placed on the groups of digits. Certain restrictions. They said here area code must be 3 digits and the first digit cannot be a 0 or a 1. So let's do this bit by bit, partially. Area code. So we have 1, 2, 3 things for the area code. They said must be 3 digits and first digit cannot be 0 or 1. So here you only have technically 8 options. This is the restriction for the area code. And then it says here exchange code must be 3 digits and the first and second digits cannot be 1 or 0. So let's put here exchange code. So for the exchange, we know it's also 3 slots. 1, 2, 3. The restriction here is that the first and the second digit cannot be 0 or 1. So here we only have 8 options here for these two, because no zeros or ones can go in those slots. And then they said the number must be for this portion, the number portion must be 4 digits and the first digit must be a 0 or a 1. So for the number part, there are 4 slots. 1, 2, 3, 4. So this here, they said it, bring this closer to each other. I'm like, why I gotta be going back and forth? Like, let's see here. So they said here, number must be 4 digits, yes, and the first digit must be a 0 or a 1. So here there are only 2 options because it must be a 0 or a 1. So they said here, how many valid 10-digit telephone numbers could be formed by applying the given restrictions? Well, that's a bit simple, because here we just know it's 8 options times 10 times 10. So here it's like 8 times 10. They said numbers can be repeated, you see. So 8 here times 10 times 10. And then for this portion, it's technically 8 times 8 times 10. 8 times 8 times 10. And then here technically it's 2 times 10, 10, 10. 2 times 10 times 10 times 10. So you may be thinking to yourself, I mean, this is going to be one number, right, with 10 digits. So you may be thinking this and then this and then this. What do you do? Well, technically, you need to multiply all these together. You see, all these numbers, this times this times this times this times this, going on and on and on and on and on. So let's see what that gives us. 8 times 10 times 10 times 8 times 8 times 10 times 2 times 10 times 10 times 10 times, nope, that's it. Whew, another big number. Let's see here. Let's see, no, we'll read it afterwards. Let's just put this here. How many zeros? 3, 6. 1, 2, 3, 4, 5, 6. So it's technically a billion. 1 billion and yo, yeah. I feel like Zuma now. Let's see. 1 billion and 24 million. Yeah, that's the number. 1 billion and 24 million. So the next one, let's see what the next one says. Determine the probability that any randomly chosen 10-digit telephone number would be a valid telephone number. So firstly, these are the number of valid telephone numbers. These are the number of valid ones. You see, these are valid ones. Okay, so for 10.3, the probability that we pick out a valid telephone number is technically that value over all the possible codes or all the possible digits. So it's going to be the ones that are valid, which is this number here, 1, 2, 3, 4, 5, 6, over the, what is this number, 10 billion, 1, 2, 3, 1, 2, 3, 1, 2, 3. You see, so this here is our probability, and then, well, technically you can work with the, let's just use the calculator, like y, 1, 2, 3, 4, 5, 6, and then, what, really? Let's not be lying. What, really? Okay, yeah. Let's not, what, yeah, and then the bottom is like 1, and then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Boom. Okay, that's like 0.1 0.24. So this is fine. You could say 10.24% if you times by 100. But yeah, that's still fine. That's the probability that you get a valid number. So this was actually not so bad at all. Looks like it was pretty straightforward. Now we're moving on to question number 11. Whew, finally made it to the end of this thing. Let's see now. Question number 11. Question 11 says here, what does it say here? It says Harry shoots arrows at a target board. He has a 50% chance of hitting a bullseye on each shot. Well, before we even work out anything, I mean, this is Harry. He either hits a bullseye, so let's say he hit, or let's say bullseye. Let's be blunt. Bullseye. That's quite bad. That's like really not nice at all. Because it's like, why though? You did not have to do this. Wow. People that are going to look at this are going to be like, what? You could have just written bullseye, but you had to botch it like that. Anyways, let's just say here, bullseye. Okay, yes. The bullseye is coming out just fine. So, chances that he hits a bullseye, you have 50%. Technically, it means the chance of missing is going to be 50% as well. Very interesting. Anyways, he has a 50% chance of hitting a bullseye on each shot. On each shot, okay, Harry shoots arrows at a target board. He has a 50% chance of hitting a bullseye on each shot. So this is like one shot. So the more he shoots, it doesn't matter. He will still have a 50% chance. So this bullseye, this is missing. Bullseye, missing. You see, this is his first chance, and then when he does it for the second time, going on and on and on. So, okay, this guy's pretty good, I guess. So here it now says, it says, oh, no. I should read question nicely. Read the question. Harry shoots arrows at a target board. He has a 50% chance of hitting a bullseye on each shot. So every shot he has a 50% chance of hitting or missing. Then he says, calculate the probability that Harry will hit the bullseye in his first shot and his second shot. Okay, so this represents him shooting once. So if he shoots once, he can get a bullseye or he can miss. If he gets a bullseye, he can also do one of two things. Get a bullseye again or miss. Here, say he missed the first time. He can now either get a bullseye or miss. So this is actually a tree diagram of him shooting twice, you see. Because first time, two options. So say this happens, also two options. But say this happened the first time, still two options. So here this is like 50%, and this I'm making sure I put the 50% symbol, because yeah, if you don't put it, then it's gonna be off. So 50%. So here, this is like bullseye. So it's like bullseye, and before that bullseye. So it's like bullseye. That's like 50% times 50%, which we know is we have to put it like that. 50% times 50%. That's like a quarter. So it's like a quarter. That's perfect. So for 11, Baba. We're at 11 now. yeah, 11, calculate the probability that Harry will shoot a bullseye in his first shot and his second shot. So hitting it first is 50, hitting it again is another 50. So that's like a quarter, which is just like, yeah. As long as your tree diagram is there, you're safe. You can just put your answer. And I should get into the habit of putting this closer to me. Okay, it says here now, for 3 marks, calculate the probability that Harry will hit the bullseye at least twice in his first 3 shots. Calculate the probability that he will hit the bullseye at least twice. Keyword here is at least twice in his first 3 shots. Okay, so if they're talking about his first 3 shots, then we have to upgrade our tree diagram. So might as well draw a new one, because forget that one. That one is fine. 11.2. So we have here, it's bullseye and then a miss. This is the first shot. And then bullseye or a miss for the second one. And put here bullseye or a miss. And then when he does it for the 3rd time, it's either these two, one of these two, one of these two, one of these two, or one of these two. See? Bullseye, miss, bullseye, miss, bullseye, miss, bullseye, miss. So all we need to do here is we have to take 1, 2, 3, 4, 5, 6, 7. There are 8 possible outcomes. So here it's like bullseye, bullseye, bullseye. See, bullseye, bullseye, bullseye. Then here it's like miss a bullseye. Yo, I should stop bullseye because I don't even know if that sounds okay. B, bullseye, and then M, and then B again. So I'm doing backwards. M, M, B. M, M, B. And then B, B, M. B, B, M. Haha, B, B, M from the back. Then it's like M, B, M. M, B, M. B, M, M. B, M, M. M, M, M. M, M, M. Whew. Okay, so now our question can be answered easier because we don't need to put all the values. We only need to put the ones we need. They say calculate the probability that Harry will hit bullseye at least twice. So we want scenarios where we have at least 2 Bs, at least 2 bullseyes. So here it's like scenario 1, 2, 3, 4. Those are the only 4 where there are at least 2 bullseye because 3 also counts. So you see here, this is just like 50% to the power of 3 because it's 50% times 50% times 50%. This one is technically 50% to the power of 3 because all the chances are 50% anyways. This one is also 50% to the power of 3 because all the chances are 50% anyways. This one is also 50% to the power of 3 because all the chances are 50% anyways. So the outcomes here, let's see, 50%, and you see I'm making sure I put the percentage symbol. 50% to the power of 3, that's like 1 over 8. So it's like 1 over 8, 1 over 8, 1 over 8, 1 over 8. So the chances that he will get a bullseye at least twice, there are 3 scenarios where that can happen. So it's 1 over 8 times 4, which is 4 over 8, which is just 1 over 2. Whew, yeah. So you see, this is clearly showing you that he can shoot forever and his chances of hitting a bullseye will still just be a half. Kidding, kidding, kidding. Let me not say it like that. Yeah. What basically all this means is if he shoots 3 times, the chances that he'll hit a bullseye are just half. Yeah. 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 No, the chance that you hit bullseye at least twice is a half. Yeah. That's what our question asked. Oh, look at that. Let's savor this question. It's the last one. It says Glenda also has a 50% chance of hitting a bullseye on each shot. Harry and Glenda will take turns to shoot an arrow. And the first person to hit the bullseye will be a winner. Calculate the probability that the person who shoots the first will be... Calculate the probability that the person who shoots first will be the winner of the challenge. Oh, okay, that's an interesting question. I think, because here it says Glenn also has a 50% chance of hitting a bullseye on each shot. Harry and Glenn will take turns to shoot an arrow, and the first person to hit the bullseye will be the winner. Calculate the probability that the first person who shoots first will be the winner of the challenge. So this one, funny thing is, this was like a full-blown, it's like a whole question of just 3 diagrams, because all you can do is, firstly, one of 2 people. So say, who's this person's name? Harry. So say Harry goes first. You know, one of 2 people can go first. Harry is either going to go first or Glenda is going to go first, you see. If Harry goes first, there's a chance, the chance that he will hit a bullseye are 50%. The chance that he will miss are also 50%. Yeah. With Glenda, same thing. Chances that you hit a bullseye are 50%. Chances that you'll miss are also 50%. Now the funny thing is, I mean, like, look at it here. Chances that it will be Harry, it's technically 50%. I mean, the chances that it's him is just 50. The chances that it's her, it's also 50. The chances that he will hit a bullseye is just 50%. We know it. The chances that he'll miss is technically also then 50%. Same with Glenn. You see, bullseye 50%, missing 50%. Now, these are the outcomes. You see, we know that Harry and then bullseye. So it's bullseye and then Harry, missing, and then it was Harry. Bullseye, it was Glenn, missing, it was Glenn. Now they said, what is the probability that the person who shoots first will be the winner of the challenge? So yeah, let's see here. Let's check what are the probabilities of hitting a bullseye if you shoot first. So this is, if he shoots first, the chances that he hits a bullseye, it's just a quarter. The chances, if she shoots first, right, the chances that she will hit a bullseye is just a quarter. So the probability of the first person hitting a bullseye is just a quarter plus a quarter. So here it's just a quarter. This is if the first person hits a bullseye. This is if the first person hits a bullseye. So I mean, a quarter plus a quarter, that's just 2 quarters, which is just a half. So there's a 50% chance that the person that hits there's a 50% chance that the person that goes first will hit a bullseye. It is just going to be, what is that? Yeah, it's going to be a half. But yeah, let's just look at this question so that we can just, you know, clean it up.